You know, this guy here, he will be able to speak to you on your level about gravity.
No,
That
but
you
I'm not
think-
asked that. It's
You
not
would
about
win.
the.
Right,
No, but this isn't my question.
Okay.
But this isn't my
Let's have
question.
a go.
But this isn't my question. My question is, how do you believe in something that you can't accept? You don't understand yourself. You don't understand the concept of density. You can't calculate density. So then, therefore, how do you believe in the concept? I asked him, how do you calculate density? He said, I wouldn't know how.
I wouldn't know how myself.
Right, so
Exactly. So how do you, as a person, understand something that you don't?
all right, let's go back.
Something that you don't understand.
Let's go back to the beginning. I've missed all this, haven't I? So just fill me in with the gaps. So
But
we're
you were
talking about
saying
gravity.
that maths can't be used because it can't prove anything, but then we started talking about why things fall.
Maths can't prove a cause of an effect. Maths can calculate what you think will happen, but maths doesn't prove what's causing the thing to happen. Would you
So
agree
what
with
do
that?
you call? What would you personally say is the reason that things fall to the ground?
They're just more dense than the medium that they're in.
But then,
Which
how
is the
would you
concept of gravity.
But then, how would you figure
Gravity
out? if
wells
something is
work
more
by the
dense?
fact that you have something
How do you
denser
know
and
if
it
something
falls
is
within
more
it.
dense?
Two at once here, hang on.
Sorry. How would you know if something is more dense?
Well, you can tell by its movement. So if I've got a helium balloon in my hand
Yeah.
and I let go of it, is the helium balloon going to fall to the floor?
No.
Why?
But then, because it's lighter.
Right, not because it's being repelled by
But
gravity or
notice,
whatever.
I said it's lighter, not that it's less dense.
Okay, so
Because
what if it was filled with sulfur hexafluoride? I'm assuming you don't know what that is.
I do.
Right, don't answer. If you know what it is, don't say. If I've got a gas and this balloon's filled with sulfur hexafluoride, and I let go of it. Do
I
you know
don't-
what it's going to do?
I don't know the maths. I don't know the numbers.
That's
so
okay.
I don't know its density.
So when I let go of it and it falls
Yeah.
to the floor, what do you then say?
I would say that it's dense. It's denser than air.
Right, and I would agree with that. But some other people
then
would
how
tell
do you
us that
calculate
gravity's
that?
pulling it down.
But then,
gravity
how do you?
pulls density.
But then how do you measure density?
Gravity pulls density. Gravity isn't based on weight, because weight itself is based on gravity.
Okay, so-
Gravity is based on
So
density.
then we've got to go back to the definition of gravity. Do we understand so let's define the term of gravity, right? Are you saying that gravity is a force that pulls something, right? Is that what you're saying?
Depending on depending on several things, gravity wells are depending on what the density in the space-time continuum is pulling down on.
Now we're getting somewhere. So basically, you're familiar with Einstein's concept of
Yes.
gravity, yeah?
Yes.
He says that gravity is the effect of the curvature of space-time. Yeah? And he also says that down is the direction in
He
which...
isn't.
No.
Yeah,
He
he
doesn't
says-
say it's the effect of it.
Effect
He
of
says it's the effect on mass.
Yeah.
No, it's the effect of the curvature
No,
of...
it's not. It's the
Yeah,
effect
it
on
is.
mass.
Google it.
Because
Google it.
space-time is affected by gravity.
Yeah,
The
space-time.
the effect, the curvature of space-time is affected by gravity. Gravity isn't affected by the curvature of space-time.
Yeah, you're right. You're
Because
right.
gravity
That's
is a
right.
constant.
The cause,
That's right.
your cause and effect were the wrong way round.
Let's define that term. So the curvature of space-time
It's constant.
gives rise to what we perceive as gravity.
No, it doesn't.
Yeah, it does.
No, it doesn't.
We perceive gravity as the effect of curvature
No.
of space-time. Google it on your phone. Space-time.
No.
General
Sorry,
relativity.
general relativity.
Yeah, the definition of general gravity.
Gravity is the effect of mass. It's
No.
it's the force that affects on mass. It's then altered by the curvature. It's then
Space-time can alter the mass of an object. It can't affect the force that is felt upon it.
Well,
Yeah.
Einstein said there was no force. Einstein said
there is a force.
No, he did.
Einstein said that the effect of the curvature of space-time is what we perceive as gravity. I'll read to you. I wouldn't normally do Wikipedia, but for the sake of a straightforward, easy answer, right? Because it's not the best citation to use. There's better ones, but when I cite them, it just goes over people's heads. So what we'll do is we'll go. General relativity, according to Wikipedia, says, and I'll read it verbatim. General relativity is the geometric theory of gravitation published by Einstein in 1915. That's World War I, right? And the current description of gravitation in modern physics. General relativity General relativity generalizes special relativity and supersedes Newton's laws of universal gravitation, providing a unified description of gravity as a geometric property of space, time, and space-time. In particular, the curvature of space-time is directly related to the energy and the momentum of whatever matter and radiation are present. The relation is specified by the Einstein field equations, a system of partial differential equations.
Yeah.
Some predictions of general relativity differ significantly from those of classical physics. Differ significantly, right?
Yeah.
Especially concerning the passage of time and the geometry of space, the motions of bodies in free fall and the propagation of light. And then it gives some examples.
Yeah.
And I'm looking for. Here we go. Einstein's theory has important astrophysical implications. For example, it implies the existence of black holes, regions of space. I'm looking for where it says. Looking for the bit where it describes general relativity as the curvature of space-time. Maybe I'll have to search for space-time. Give me 1 second.
The curvature of it does influence.
It influences it, but it doesn't.
No, that's the effect. The curvature of space-time is the effect. But we perceive that effect as an orbit.
It's not. It's the other way around.
No, it's not.
It is.
Right.
Because
Einstein
the denser something is, and the more mass it has, it's gravitational.
How is the world? The Earth.
Einstein says that the sun and the moon, or the Earth, the sun, the two bodies,
Yeah.
they have an interaction with each other that
Yeah.
curves space-time.
No.
No.
Yeah.
It's not. It's their mass and their density alters the curve of space-time, which
Right.
affects the pole.
Because if you picture
No,
the
it's
We're
actually
saying the same thing.
No, it's
You're
not. You're
not.
cause and effect to the wrong. You're saying that because of gravity we have space-time, right?
No,
No, you're saying because of the curves we have gravity.
No, I'm saying that Einstein says that the effects on gravity is the effect of the curvature of space-time. That's caused by mass interacting with mass. I'm describing the effect that we perceive as gravity. That's what he says. Let me get the. Let me
That's
go to
not what
space-time.
gravity is.
It is.
Gravity isn't just the curvature, the curving of space-time. It's the effect of a force on mass.
Right, so reading from skyandtelescope.com, curvature of space. I'm just ringing up some on YouTube, just random one. Curvature of space-time. According to Einstein's theory of general relativity, massive objects warp the space-time around them, and the effect that a warp has on objects is what we call gravity. So locally, space-time is curved around every object with mass. So it's the warping of the space-time that is what Einstein says is what we call gravity. It's the perception that an object is following a curved path, but it's actually going straight. It's just warping space-time around it. That's what Einstein says.
Yeah, because it's
Yeah.
the idea of a gravity well.
Yeah, it's
Okay.
gravity well.
Yeah, you can apply that however. But my point is that that's what Einstein says gravity is. But the problem is we're told that an accelerating object, an apple for example, that falls from a tree, that's an accelerating mass.
Yes.
And by Newtonian principles, any mass that accelerates is subject to a force. Hence the phrase F equals ma.
Yeah.
Well, if Einstein says that gravity is the bending of space-time, my question is, what force is making the apple move?
Right. That's because you're
crossing
Th-
quantum mechanics
there's,
with
there's
Newtonian
quantum
mechanics.
mechanics and
Exactly.
Newtonian mechanics. No,
Because they measure two different concepts.
yeah, one's on a micro.
One of them's considered to be current science, and the other
Both
they
are.
both are.
No, they're not.
Newtonian
They both
mechanics
are.
is used in basic science. I have
know.
just completed a science degree. I use Newtonian mechanics
I
and
have
use
science
quantum
A-levels.
mechanics.
Like,
Right, get your phone and look up the word gravity now and just say it.
no, but that's because there's a different gravity can be used
Newtonian
in
mech-
different equations. There's G equal, what's it? W equals mg, which directly relates weight and mass. But then you also have F equals what's
F equals ma.
What? No, because Newton also has another equation which explains quantum mechanics, and he still uses gravity in it.
Newton didn't know about gravity back in the day. He specifically
Newton
said.
came up with gravity.
Newton,
Newton
did.
said-
Newton's the
Yeah,
one that-
Newton dropped the.
It's Newton and
Oh,
Hubble.
he came with F forces to MGH.
Newton
Einstein-
wrote in his letters to David Bentley, he said, "Do not ascribe gravity to me." Literally said, "I don't want anything to do with it." And 100 years later,
He
gravity
didn't want
was.
anything to do with it, but so for him to not want anything to do with it, he must have known
must
about
have
it, which
had
you
to come
just
up with
said
it.
he didn't know. He came up with the equation of F equals ma. He came up with the equation equals
Are you familiar? Are you familiar with the Cavendish experiment?
Yes.
Right. What do you think the Cavendish experiment proves?
Nothing.
Nothing.
No.
Okay.
No
Why?
experiment proves everything.
What was the Cavendish?
There's nothing. No experiment
Every
ever definitively proves anything. What it does is it provides more evidence.
Every experiment proves either your null hypothesis or your alternative hypothesis. Do you agree with that?
No,
No.
because it
So
can,
what's the point of science then?
because it can
Because it
concur.
only encourages evidence towards a certain theory, but nothing can ever be 100% proven. That's the whole point of science.
So what-
That's the whole point of why your whole argument, when you definitively go, no, you guys are wrong, we are correct, proves the fact that you're not scientists at all, because you're completely unaware of any other arguments or completely unwilling to accept any other theory, which makes you really bad scientists.
What do you mean when you say scientists? Because to me that means compliance with scientific method
People
by
who
the
search
definition.
for the truth.
No. There's
People
a
who
definition.
investigate the laws of the universe.
No, but adherence to
People-
scientific
people
method makes you
who-
a
No,
scientist.
but okay,
No,
me personally, it's looking into the laws of the universe.
Yeah,
and by
personally,
you
I'm not asking
describing as
personally.
It's
I'm not
people
asking personally, I'm
it's
asking
people-
generally. What
it's-
is a scientist?
someone who
it's
just
some-
studies the laws of the universe.
No,
It's-
somebody that adheres to scientific method, that's a scientist.
It's
Okay, but
someone
what's
who
science?
tries to disprove
Anybody else
but
is
they can't.
anybody else is a
Define
theoretical.
science.
Define science as a study and the observation of the natural world through observation and
So
experiment.
if you want to look into the natural
Did you
world,
hear what I
and
just said? You seem to have interrupted. I don't mean to be rude, but science is the observation and the study of the natural world through observation and experiment. That is science,
okay, so your science.
not my science.
No, okay, but okay. So what do you call this? You proving flat Earth?
No,
What's that? So what do you call it then?
we're questioning what is the evidence that proves that the Earth's turning, that we've got
Okay,
gravity,
so
that
what
the Earth is
evidence are you
curved.
using? Are you using scientific evidence?
We're pointing out that this is not science, but it's believed to be science.
So what would you call it if it's not science or an art?
Pseudoscience, by definition, it's not adhering to scientific method.
Pseudoscience.
Yeah, by
So-
definition, it
there's-
doesn't adhere to scientific
But
method.
surely,
But what method are you using then if you're not using scientific?
That's the point. Everything.
But what are you using?
We're asking where is the scientific compliant
what's
method
yours?
which shows that the Earth
Okay,
is
so
turning.
what's
but
your
then you're
theory of
disregarding
methods?
you're disregarding the science that proves it and then saying where is the science that proves it?
No, what science proves that the Earth turns?
I mean, angular momentum.
Momentum.
Right, so where does it get proven in science?
Or angular momentum?
Yeah,
They
that the Earth
by,
turns
by
with angular
experiments
momentum.
in labs, by using different equations, by
The
endlessly
ISS
testing.
observing it?
By,
Observing another planet who are spinning. If all the other are spinning, Earth
Yeah.
Right, with regards to
but the thing is, angular momentum is tested again and again and again, and it
How does
works.
satellites
angular momentum
work
is a
then?
thing, but it doesn't apply to Earth if the Earth isn't turning. And there is no science that
But
proves
they-
that the Earth is turning. That's my point.
There it is.
So how do you prove that it's not turning? What points
Because
you in
there
the
is no
direction?
science that proves that it is.
That's not what you prove, so by just going, oh, there's nothing there to prove it, so it must be the other thing. Because then you don't
we're
have
not saying
anything
it
for
must be the other
that.
thing. What we're saying is everybody accepts that the Earth turns once every 24 hours. And what we're saying
Yeah,
is,
the sun. That's the proof right there.
right,
Because
but
it
do you
appears
realise-
once every 24 hours.
Yeah, so you observe the sun, right? We can say that the sun's an observed phenomenon. Well done, that's step one of scientific method. The other steps involve making a hypothesis where you correctly identify a valid independent variable and
Okay,
a valid
so
dependent variable.
my-
You've got the sun. So
Yes.
how are we going to prove that the sun is causing the Earth turning?
But,
Because that's what I'm asking. I'm asking how do we prove in science that the Earth's turning?
no, but the
The
sun
sun
doesn't necessarily cause the Earth
Well,
turning.
you just said the sun. And then
No, that proves that the Earth turns. It doesn't mean.
So you just said that you just
No,
said
no,
No, no, no, no, no, no, no, no, no,
They're two
no,
different things.
no,
The
sir.
sun-
Just because the
the
Earth
sun-
turns doesn't mean that the sun is causing that. What it means is that because of the sun, we can observe the fact the Earth is turning
Point taken, but my question is how do we prove in science that the Earth is turning?
by maths, which you said
No,
isn't.
maths doesn't prove cause. Maths calculates an effect.
Okay, so how do you
observing
suggest we
another
prove it then?
planet. If another planet are
How do you
spinning,
suggest we prove
the
it? What do you
Earth can be
expect?
one
That's what we're
exception.
asking. That's
Because
why
all we have right now is maths.
Right, we have things that measure momentum. They're called
Yeah.
gyroscopes. We've got ring laser gyroscopes, fibre optic gyroscopes, and we've got mechanical gyroscopes.
Yeah.
And these things can be used to measure momentum, right? None of them measure the Earth turning. All of them
Because
tell us
they're
that the
on the
sky's
thing
turning.
that is turning.
Yeah,
So
but-
if you're on something that's already turning, it turns as sort of a stationary thing because
So-
it can't measure.
So do you agree that a gyroscope maintains rigidity in space? Yes or no?
Yeah, but you can use a gyroscope.
So if I put a
If
gyroscope...
you put it on the floor, it won't calculate the momentum because it's in itself moving with it. So
Yeah,
the
that's the
momentum of the
whole-
thing
yeah,
is
yeah,
equal.
Well,
If,
you
however,
already
you
know
put
what
one
it
up
is.
on the Earth.
That means you disagree that they maintain rigidity in
No,
space?
no, if
No,
they were
because
placed
there
on the
isn't
ground.
a certain.
Yeah, but the ground's turning.
No, but if you were to place it above the ground, it would calculate the momentum of it.
Yeah, but that means planes that basically fly around the globe constantly have to correct
No,
for
you have
the
to take it
curvature.
out of the Earth's atmosphere, out of its gravitational potential to serve for it, like.
You don't need to be out of the Earth's gravitational
But you
potential
do,
to
because
measure
that's
the
what-
momentum.
The momentum because it's connected through almost like a string.
But do you agree that the alternative interpretation of that indicates that we might not be turning at all?
No.
Why?
Because that's absolute idiocy.
But then also,
Like, I'm sorry to
So
be rude, but
no, you're not being rude.
No,
What
I
you're,
don't think
you're
because-
accepting the gravitational effect. The potential is the reason why the gyroscopes are not measuring momentum. And I'm saying, but it can be interpreted another way, and you just dismiss that flippantly.
but then it's also because there are different ways of calculating momentum. When you're up in the
Right, I'm
air,
not interested in calculating. I'm interested
but I am.
demonstrating,
I am because
proving.
you prove it through using maths because maths
No,
is a
you don't
constant.
prove cause in maths.
You do.
You don't.
You do.
Right. So, give me an example where maths proves cause.
What type of thing? Like
Any.
okay, you can.
You're very quiet at this point. Are you going to
No, no,
correct
no,
your friend?
no, no, no.
Right.
Because I'm on his
Because
wavelength.
you can do it with.
So okay, so if you're both on the same wavelength, give me one example where maths proves cause.
It can prove the cause of the formation of black holes.
The speed of light.
Yeah.
Theoretical physics.
Yes.
Speed of light.
Theoretical physics.
Yeah, it's
Proven.
not theoretical because you can control it using the Chandrasekhar limit,
Speed of
which,
sound.
which proves it.
Speed of
Maths,
sound.
maths can be proven by it can prove the speed of sound. It was calculated by the speed of sound. You can also prove it.
All right, my question was, how do you prove
Speed of light.
cause? How do you prove cause with mathematics? And you said speed of sound. Then you said we can calculate speed of sound.
We did calculate the speed of sound.
I
that's
agree.
not the cause.
But that's not my
That's-
question.
that's 'cause it's
My
different.
question is, how does math prove cause? Give me one example anywhere where maths proves the cause
Astronomy.
of an effect.
Astronomy.
Observational science.
Yeah.
It's not a cause and effect relationship.
No,
It's
it is.
observation.
No, it is because the cause of having a mass greater than the Chandrasekhar limit means that you can then predict what it's gonna form into.
I
That is
agree,
exa-
but that's not proving a cause.
No, it is. It's proving
No, it's
that
not.
It's proving that the cause of stuff like black holes, as opposed to the cause of neutron stars, is the mass relationship.
Right,
It literally
relationship,
proves
yes,
that.
it's correlated.
No,
It's
no,
not
no,
proving
no.
cause.
It is. It's proving
You're
it.
wrong.
It's not. I'm using maths to show that if you have mass of a
To
certain
correlate.
size.
I'm asking cause. You're demonstrating correlation.
No, I'm not. I'm
You
proving
are.
that the cause
You're not
of.
proving anything.
I am using maths.
No, maths doesn't prove anything.
It does.
calculates
It
correlation.
proves that when you have mass over a certain limit, it forms different things.
Do you agree that the scientific method is the definition of science? In contrast, non-adherence to scientific method is
No.
pseudoscience.
No.
Look
Because
at
the definition of science is
It's
the
so-
study
it's
of the
so
laws
mu-
of the universe. And
So
not
if
the
I-
laws of the universe.
if I get the definition of pseudoscience on my phone and it doesn't say,
I'm not asking about pseudoscience, I said define science.
I'm asking you, does science and the adherence to scientific method, is that important in this context that we're talking about? You have to adhere to scientific method, yes or no?
Yes.
Right, so
Because otherwise, how would you measure anything?
right, so agreed, you get your dependent variable. So where in any scientific experiment is maths your independent variable?
Because you alter the value of
Because
x
you
in
can
a
alter,
equation.
yeah, you alter value of mass. That's how they proved F
That's your
equals ma.
hypothesis.
No, they then proved it
By doing what?
by experimenting it.
Right, but the maths isn't the cause. Maths is the calculation of the effect.
But any quantum
No,
mechanics
no, no,
equation
no,
that you've ever done
acceleration.
is done by mathematical
Acceleration is
proof.
And that's why
Because
quantum mechanics is a really highly debated topic.
In F equals
and it
ma,
reflects Newtonian
mass
principle for
isn't.
gravity as well.
But what if
You
it's
said-
so highly debatable? How come it's changed completely? Apparently, according to you, taking over Newtonian mechanics. It's so highly debatable.
Quantum mechanics.
No, the gravity it's replaced gravitational calculations in masses underneath the value of an atom.
Yeah.
Not anything greater than the atom. That's still used for Newtonian mechanics, so, it hasn't
so do
overtaken
the
it
laws of
completely.
quantum mechanics not apply to the rest of the world at the macro level, or do they still prevail?
No, not at the macro level. The macro level still use Newtonian mechanics. Only at the nano level would it be used for quantum.
So the answer to my question is no. You say quantum mechanics doesn't apply at the macro level.
Depending on the equation.
Depending on
not
also
depending on the
depending on
equation.
what
No,
you're
but it
trying
is.
to
In
prove.
experiment.
No, it
No, but it is
Quantum
because
mechanics.
each equation includes a different value of x depending on what you're calculating.
That's why.
Quantum mechanics,
No, but
yes
isn't
or no?
that?
Quantum
no, but
mechanics
no.
does not affect anything at the macro
It does.
level.
It does in
course it
circumstances.
It does
Rules
because
it.
it's a
It
chain
does.
reaction, because everything's
Because-
made at a nano
Right.
level.
So
it's
that means
collective.
quantum mechanics
But then as
prevails.
soon as you collect something, things behave differently because of the level of interactions that you have between other materials.
So it pervades.
No, it's not that one is superior
No,
to
to
the
the
other.
other, they're
It
both
just-
used
they're-
in contingency with each
Yeah.
other. Because that's the only way it works.
They only work, and it's why De Broglie's hypothesis was so influential because it was the first thing that linked quantum to Newtonian mechanics using Planck's constant. And that was the first moment people went, oh shit, these two could actually be related. These two are fundamentally the same principles of the laws of the universe at work. They just explain things in a slightly different way.
So are you saying
And yet mass is at the base of all of it, showing that both of them are correct.
that may well be the case? But my question is quantum mechanics different, not applicable or applicable to anything beyond the macro level? Yes or no?
It's not different. Quantum
It's
mechanics
not
is
different.
fundamental.
Right.
It's
That's
not-
my point. So
it's
quantum
not different,
mechanics
but it
did
can be
replace
ca-
Newtonian concepts from
No,
It
because
didn't, because the Newtonian concepts at a macro level, if you say, like, if we're talking macro, as in like astronomy and the space, then you need the quantum because the masses get so large that they affect the space-time continuum and effectively alter different relationships between things that aren't just at normal levels, like round here.
Feynman, are you familiar with Feynman?
Yeah.
He said that quantum physics demonstrated that Newtonian principles of gravitation were wrong. Not a little bit out, they were wrong. So unless
At what level?
At what level?
quantum level.
And the discovery was made then in the discovery of quantum mechanics, first in the behavior of light and then in the behavior of matter, and finally culminating in 1926 with the full equations of quantum mechanics, which told us that the laws of motion of Newton were not right and had to be modified to other laws, which are quantum laws of motion.
Well, yeah, because you're talking about quantum mechanics. Like, at the quantum level, a particle doesn't behave in the same way that it does on a macro level.
No.
They behave completely differently, so you can't apply the same
How is that
theory.
true?
Because they've proved it.
Because like a particle.
Let me guess, maths.
Because no, they've done experiments. They've taken visible observations. Young's double split.
Visible observations.
Young's double split experiment,
Rutherford's gold foil experiment. Young's is double split.
De
quantum
Broglie.
eraser
The whole point of De
No, no,
Broglie.
The
no.
double slit experiment.
Yeah,
Young's double split, where he fired a particle at a single slit and
Yeah.
got two observations.
And got diffraction because it behaved
Because
more
it
like a
behaved
wave
like a
than a
particle.
singular particle.
Oh, sorry, yeah, it behaved like a wave. And yet when Rutherford fired
So what-
particles
That's
at a
also
gold
called wave
atom,
particle
it found it's a
duality.
particle.
What do you understand that the quantum, the double slit experiment proved?
Wave particle duality.
It proved that particles don't behave like, well, when you look at things like an apple, those particles on a macro level behave as a solid. However, when you go down to actual quantum, everything goes a bit mad, and you have a wave particle duality in which a single thing can exist in a double state.
Yeah, that's true. That's true.
And that was then proved and observed. But it's not to say that when you're measuring, say, the weight of an apple or the acceleration of an apple, that quantum doesn't apply.
So what we've just been discussing, right, regardless of who's right or wrong, we've just been arguing about whether real-world experiments to do with atoms or whatever prove points, right?
Yeah.
But this started because you said that maths proves things, and I said maths isn't proving a cause and effect relationship; it's calculating the effect. Back to that point, can we at least agree that maths isn't a cause of an effect? It's a calculation of a result
Maths,
or a prediction, and it fits in with the hypothesis, not the independent
maths
variable.
can be used to prove an effect,
No,
but
it can't.
maths is an underwriting principle
Yeah.
that everything adheres to.
But it doesn't
So
prove the
surely
cause of an effect.
surely by understanding maths, you understand why things work. It's like
like
understanding French
biology,
language
like
helps you
studies the
understand
human body.
what people
Chemistry
speak in
then
French.
understands how the
It's the
chemicals
same
in your
thing.
body
It's
react
not
with
right to
physics
say
and
that
stuff
maths
with how
proves
those
cause.
chemicals made
That's
particles.
fundamentally
Maths
wrong. It doesn't
explains how the
maths is
particles.
numbers. You're painting by numbers.
Everything
Maths-
fundamentally
maths
comes down to
proves
maths.
that everything adheres
No,
to.
it doesn't prove anything. All maths does.
There's a whole area of maths dedicated to proving.
Yeah, theoretical physics.
No,
that is.
it's, no.
It doesn't prove cause.
It proves stuff like n plus n equals n plus m, or that PQ equals QP, and all these different algebraic things. It shows that there is a fundamental law to everything in the world.
Right,
And
so
then-
when we get-
and all the observations
let's apply
are
that.
basically trying to understand.
Let's apply what you just said. If I get something and I drop it to the floor,
Yeah.
it hits the deck and we can calculate how long it took and how fast it went and all that, right? And we can use maths to do that.
Yeah.
If I say, when we have the effect of something falling to the floor, let's just call that the number 4, just because 2 plus 2 equals 4. You can get to 4 by the object falling to the ground with 2 plus 2. But I can get to it with 1 plus 3, and you can get to it with 3
But that's
plus
why
1.
maths proves that.
No, it doesn't, because
No,
there's
hold on,
three
because
ways to get to 4.
because that's the whole point on proving. The point of proving is that m plus n, so one constant plus another constant equals the same constant plus the same constant.
Right.
So what you're saying is effectively m plus n equals p plus q, which still works.
I agree with that.
Which works. What I'm saying is you can prove that the 2 I had and
Yeah,
the
so
2
I
say
graduated,
inexperienced
there was
halfway
research
is what
and
gave us the thing at
for a
the
while,
end.
that's what
But you can also prove that the 1 you had plus the 3 you had equals the 4 when it hits the ground.
But you can only-
Maths proves that.
No, you can only prove that by proving it, not by describing it mathematically. All right, a squared plus b squared equals c squared, right? That's a lovely expression, and we can draw it and we can calculate it.
Yeah, on
right.
a 2D plane.
Yeah, but it only works if you demonstrate that that is true. Then you prove that the maths is matching reality, and therefore you accept the hypothesis that a squared plus b squared equals c squared.
Yeah.
But it's only when you do that then you can say say, yeah, I've now proved that a squared plus b squared is equals c squared. But before you actually do it, you're just calculating it. But that's not science. That's
That's what I'm saying. Maths is an underwriting language
Right,
that is
but
fundamental to everything.
science is not
and all,
maths.
no. And all science is it's applying maths. It's trying to figure out
experiments.
why
Science is
stuff happens
experiments.
using maths to explain it. If they can prove it by math, it's like me saying,
No,
"Oh,
no.
I can speak French," and just making noises. What I need is then a French person to say either yes, that's correct, or no, that's complete gibberish. What you do
where
in
you're
science
going
is you
wrong-
come. No, hold on. One thing you do in science is you say, "Oh, well, what I've got is d plus f equals 9 squared," and then suddenly you go to a mathematician and they say, "Well, no, because that doesn't equal that." Or you sit there and say a squared plus b squared equals c squared, and then you go to maths, you try and apply it, you see if it works, and then maths either says, "Yeah, you've right, bang on, you
Yeah, but it
proved
wasn't
it,"
the maths.
or
It wasn't the maths that proved
no,
that a
but you
squared
used
plus b
maths
squared.
to prove observable.
No, you use maths to predict that
No,
that's what
you-
your result will be.
but
And
you
when
said
you test
earlier
it and
you
you get
can't.
it, then you say, I accept my alternative hypothesis and I reject my null. Because it's all about scientific method. The maths.
But then how do you prove all that?
The maths only fits in the hypothesis stage where you predict your effect.
No, it doesn't.
Yeah, it
'Cause
does.
no, it doesn't. Because what you're saying is you predict something, and then you just
Maths
sort of
isn't an
find
independent
maths
variable.
that protects
Maths
it.
is not an independent variable. Do you
No,
agree?
but that's what I'm saying is, where you said that effectively you do a study, you do an experiment, and then you sort of find the maths to work, right? That's sort of what you're saying.
No, you make an observation and you wonder what causes that. So leaves falls off tree, right? You wonder what causes it, and then you can calculate that maths is going to involve it in some way.
But you're saying
And
you
it doesn't mean
can.
it's right.
No, but you're saying you can do it. What a lot of people do is they try it, and it fails, and then they go, right, where have I gone wrong? Einstein didn't just come up
But
with
when you try
relativity.
it, that's the application of your maths, yeah?
No.
Yeah, of course it is. You've
No,
predicted- you've
when you're
calculated something.
when you're trying it, you're seeing whether or not what you're doing and what your ideas are adheres to the universal fundamental language of maths, which is unchanging. If it does, fantastic, you're more than likely to prove something. What people then do is they then spend the next 100 years trying to disprove you, and when they can't, people sort of go, you know what, I think he's got it right.
I'm going to ask your friend, and I don't want you to interrupt her answer.
Alright.
Can maths be an independent variable in a scientific experiment? Yes or no?
Yes,
How?
because you can alter an equation.
Yeah, but
The
what's
whole
what's-
the equations
what's the
aren't just
definition
right.
of an independent variable?
Something that you can change in an experiment.
Yeah, and it's the presumed cause of the effect. That's
Yes.
the key bit. It's the presumed cause.
Okay, but math. If you're asking that question of can maths be an independent variable in a scientific experiment, yes, it can. For the fact that if you are trying to investigate what the mathematical equation is, you alter it so it fits your then equation. So which
Right.
in that case, it would be an independent
But if
variable.
you're going to say that maths is your independent variable in a scientific method, I'm going to call you a fake scientist.
No, because that's
Would you
what
like to show my science degree to you?
But that's what I was saying.
No, it's not about your science degree. It's about whether you adhere to scientific method or not.
No,
If
that's-
you don't
that's what
adhere
I'm
to it,
saying.
you're not
Yeah, but
practicing science.
That's what I'm saying. If you're trying
So
to
what am I
calculate something
practicing?
falling off a tree,
Pseudoscience, by definition.
So what's pseudoscience?
Non-adherence to the scientific method.
That's not. That's a pretty poor definition.
Sorry, I really don't
I'm
want
gonna
to
get on
shut
screen.
you down here. But effectively, what you're saying there is what I was saying. Is the way that if you're trying to calculate something,
Guys, look, pseudoscience definition, a collection of beliefs or practices mistakenly regarded as being based
No,
on
exactly,
scientific methods.
exactly. So
Right,
with
so if
science,
you're
if
telling,
something falls
listen,
from
if
a
you're
tree-
telling me your independent variable is maths, and I'm
No,
saying
it's
that
not always, but it can be.
No,
Your
it
question-
can't. It can't.
Just explain how it
It's a
No, no, no,
cause.
what I'm saying-
Maths isn't a cause. It's a
but what I'm
causative
saying is,
effect.
if you have something falls from a tree,
fake
and I go, force
I have a degree too,
equals-
and a master.
But it's like,
Right.
if an apple fell from a tree, and I said, oh well, the
What's the cause?
the rate that fell was,
Yeah.
I don't know, a force times.
Yeah.
gravity.
You can come up with a
Like,
number.
I could come up with anything, but that's not
Science.
That's not what science is.
Correct. That's pseudoscience.
The way you prove it is by somebody saying,
Prove
oh, I
what?
think it's that.
We're trying to
But-
prove the cause of an effect in a scientific experiment. We're not trying
No,
to calculate
you're
how
trying
long.
to,
You're not trying to calculate how
you're trying
fast
to
it falls.
prove why stuff happens effectively.
Cause.
And so when I say, oh, it
Cause.
happens because of this,
Yeah, cause.
yeah,
And then the effect is the observed phenomena.
yeah.
That's the
If I'm
dependent
just sort
variable.
of saying, oh yeah, it was affected, it was caused by this,
Yeah, where does
but I
maths
just
fit into
just
that?
make stuff up. That's not using maths
No.
correctly, because someone will then come along and
But where
say,
does the maths fit
well,
into
I've- Because I can just make up maths. If you're saying maths is an independent variable,
Answer my question. Where does maths fit into your independent variable?
because the way I try and prove it is using maths.
No, you do the test.
Yeah, no, that's what I'm saying. But because maths is a fundamental law,
It's a- no,
it's,
it's
it's a language that is that it is correct. If
No.
you can find it, no, what I'm
Maths
saying
is a correlation.
F equals ma is correct. It's been proved billions of times. It is correct. So if I said F equals g omega, then someone would come along and say, well, no, because I tried that and I got this result. And then someone else would come along and say, well, actually, I tried it like this and I got this result, which is closer to yours. And then gradually
All right.
people come together
So
and everyone
let's
goes,
do F-
well, I did an F equals ma and I got this result.
Right,
I
let's-
did it
let's
on
go
this,
with
it
F
worked."
equals ma.
And suddenly you have a maths, which is an underwritten language which cannot be changed. And suddenly you realise that me going F equals g omega is complete nonsense.
Listen.
And the dudes who went F equals ma, they've got it right.
Listen, if we,
Because
let's,
it cannot
go,
be
let's
disproved.
apply F equals ma. If an accelerating mass accelerates, it must be subject to a force.
Yes.
We can calculate that force. We know that that mass will fall at that rate, and we can calculate that force.
Yes.
Can we prove the force exists just by calculating it?
What else is it?
Yes. Because otherwise you have,
What happens if you get your maths wrong and you let go and it doesn't do what you thought you were going to do?
then you try it again.
No,
do
You
different
keep
levels.
going.
No,
you
you-
keep going.
No,
change
you-
the
And if,
maths.
it
No,
still
you,
doesn't
ex-
work,
you
then
accept
play
your
around.
null hypothesis and you reject your alternative
exactly, but
hypothesis,
that's the
and
point
that's
of
science.
maths.
Oh, and then you
no,
just stop.
science, not maths.
Science is applying maths.
No, you're wrong. It's not applying maths.
Okay, okay.
Applying
Yeah,
maths.
and so you play around with equations.
maths itself
Einstein
isn't a
didn't wake up
cause.
with one day and discover like
Have you got?
these
Do
deep.
you have a degree?
Yes,
In physics.
I did. What I did A-level in physics.
Did you get a degree in physics?
I have a degree in quantum mechanics.
Quantum mechanics. So you guys are struggling with the independent variable in
No, we're
scientific-
not.
You
We're
are.
not.
This is not
What I'm,
maths.
what I'm saying
I
is,
did
if
a
I
degree in
can,
quantum mechanics. I think I knew the difference between an independent variable is.
Yeah, you agree it's the presumed cause.
No,
It's
it's,
the
not
thing
the
you can just
presumed
change.
cause.
Do
It's
I
the
need
thing
to-
that you change to explain the cause.
Yeah, it's the presumed cause. I mean,
That's not
No,
the
it's
presumed
not.
cause.
Yes, it is.
The
Do I need a
presumed,
citation?
no, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable.
how you use maths. What I'm saying with maths is, if you use it as an independent variable and you just kind of play around with it,
can't
sooner
use
or
maths as an
later
independent variable.
somebody will turn around and say, well, that's not right because I've found it like this.
It's
And
the
then we
basic
realise
fundamental
that.
of the universe is maths. That's evidently why anytime you plug anything into how our
It's
current
something
law works, you can get a mathematical equation out at the end of it. That's not
Yeah.
just like random convenience. Biology is explained by chemistry, chemistry is explained by physics, and physics is explained by maths.
Right, would you accept
Maths is the fundamental.
Would you accept an EDU citation from an education establishment for an independent variable? EDU, would you accept it as a credible citation?
Sure, why not? But depending what it's for.
So, I've just Googled it. So, this is the University of, I'm not sure where this is, UC, whatever USC
That's the
like.
social sciences though.
Yeah.
That's not the same thing.
Okay, well, so I can go to another one. Let's go to another one.
Yeah, not a social science.
Okay, let's go to another one. It's a bit slow, my internet, so bear with me. Come on.
The thing with maths is once you've found it,
It's not maths. Oh, hang
once
on.
you've found it, you can
Independent
prove
variable,
science is
presumed
correct.
cause.
So say, okay, so you're doing a computational experiment.
Sorry?
Say I'm doing a computational experiment.
Yeah. A computational experiment is not an experiment
Why?
because it doesn't adhere to scientific
What's the
method.
definition of an experiment?
What?
What's the definition of experiment?
A practical demonstration of your cause and effect relationship. It's a hypothesis test.
Yeah, so if I'm doing it on a computer, how does that affect that? Because I'm still
Because
doing
how-
a practical.
No, you're not. You're computing a cause and effect there. You're not actually experimenting. That's not. It's
Well, I
missing.
am experimenting, changing something to observe, to explain an observed observation.
Yeah, but if you're doing it on a computer, that's not complying with experimentation because you're
Why?
not because you're failing to manipulate your presumed cause
No, but
in
you
your
are
experiment.
manipulating 'cause you're
You're not. You're
changing
computing it like maths. You have to
No,
physically change it.
because you write your own code, you come up with your own equations.
Yeah.
And when they don't work, you sit there and think, right, what have I buggered
How
up?
does
Because
it-
if the math doesn't work, then you know that your science is wrong. And so you keep playing around with the science until it adheres with maths, because maths is unchanging. Einstein didn't just wake up one day with one equation in his head that suddenly proved relativity. He thought about it, he did experiments on it. People like Kepler, people like Lenz, they all
Right.
built on it. And then realised that actually it's correct.
University of Indiana got a glossary of terms and variables, right? It's just a dictionary glossary. I'll read what it says. Independent variable. Independent variable. the presumed cause in an experimental study. All other variables that may impact the dependent variable are controlled. The values of the independent variable are under the experimenter control. Strictly speaking, independent variable should not be used when writing about non-experimental or computerized designs. Presumed cause. It is presumed cause. That's why math can't be your independent variable. Come on, this is
No, that's what I'm saying.
No, it's not. You were saying math can be the cause. You've just
no,
flip-flopped.
no.
That's a flip-flop.
Maths doesn't.
You've just flipped your position.
Maths isn't.
Maths is the fundamental
Maths is
of
a
everything in this
constant.
universe.
True, but it's not a cause in the
No, but
scientific
okay,
experiment.
Can I finish? Maths is the fundamental of everything in this universe. Everything can be whittled down into maths. As far as we can observe,
You can't
everything
do that.
as far as we have observed, everything that exists in this current universe can whittled down into mathematical equations.
But
Whether you believe it or not,
Yeah,
how
but-
many equations can be
Hang
whittled
on,
down
hang on.
into maths?
Step-
No, I'm finishing this point.
Yeah, but hang on, you're making a massive point. So let me respond to that
No,
one point.
because I haven't finished this point yet. You can respond to it once I finish the entire point. Can we whittle it down into mathematical equations? Therefore, the mathematical equation is the cause of everything of the universe. If everything can whittle down to that equation, because that equation is putting out the cause.
Right, listen. You said everything can be whittled down to mathematics in the observed universe.
Yes.
Your first step in your scientific method is to perform an observation.
Yeah.
Observe a phenomena.
Yeah.
So if you're going to claim that everything can be whittled down to mathematics in observation, I'm going to say that's only the first step of scientific method.
Yes.
It's not the full procedure.
No, exactly.
You're falling short. To get it to be scientific, you have to go and then perform experimental tests, and
Yeah.
you're not
And
doing
try
that
and
based on observations. That's why astronomy is not science.
Yeah, okay, but...
is.
It isn't. It's
really is.
It's
Well,
observation.
observing...
But
Right.
no, it's
Experiment.
not. It is. It uses maths. It uses experiments. It
doesn't.
Also,
give me
nobody-
more experiments in
CERN.
astronomy.
CERN. They're
Right,
using
so-
they're using quantum mechanics to understand how.
How? How are they doing an experiment on the sun?
Because they're using quantum mechanics and then the maths with that, which they're then applying to astronomy and seeing if it works. And then it works, and then they know.
You have to.
But
You can't just
observe is not
observe and go,
science.
oh, there's
You
the
need
maths
experiment.
right there.
No, it is. It's
It
one,
is
it's
experiment.
one
It's
step of
experiment.
science.
It's not
Yeah,
the
but it's
end.
still science.
No, but it's incomplete. If you don't adhere to scientific
Yeah,
method, you're a
and
fake
then go
But
scientist.
it's part of science. I'm
Well
not
done.
I'm not
Well
saying
done.
you
You've observed.
stop.
You've observed something.
That's what I'm saying. I'm not saying you stop. What I'm
Right,
saying
so-
is you
all
then
right.
go on and you
So
try and figure out
does-
the maths.
How does astronomy go to the next step where you make a hypothesis, where you predict an independent variable and
Because
a
they
cause
did it with
and
gravitational lensing.
Right, gravitational lenses is what? It's an observation, yeah?
Yeah, but that's what I'm saying. They did it with gravitational
What's
lensing.
the
where they looked-
cause? What's the cause?
Mass and the curvature of space-time.
Who wiggled it to prove that it was the cause of the effect that they claimed
What do
they
you
were
mean, who
observing?
wiggled it?
You've got to manipulate your independent variable. Who wiggled the mass
No,
to prove that
because
it was
what
the
you do,
cause
yeah,
of the
I'm
buzzer?
not saying that you wake up one day, you come up with a formula, and that's it, bang, done.
Yeah, you did say that a minute ago.
No, I didn't. I
You
never
did.
said that at all. Because what you do in maths is you come up with something, and then you
Gravitational
try
lensing.
and prove
Let's
it.
stay on gravitational lensing. You
Okay.
said gravitational lensing was science. I said they observed something.
Yeah.
What caused it?
Mass and the curvature
Right.
of space-time.
Who wiggled the mass to prove that that did cause the perception that you believe, the phenomena that you
mean-
believe you're observing?
Lens.
The answer is nobody.
No, they did.
They didn't. Nobody
they
did.
did.
So who can manipulate
Lens
mass?
did. Nobody manipulates mass.
Right, so it's not science.
Mass is a constant.
It's not science unless you can manipulate your independent variable. You're not adhering
Mass
to
is a
scientific
constant
method.
value. They proved that. E equals MC squared.
You have
E
to
equals MC squared.
We've just
Einstein
read it.
proved that mass
We've
is a
just
constant.
read. We've just read. You've got to
Mass,
manipulate.
mass is not an
No,
independent
because that's
variable.
not manipulating mass, that's just changing
That's
the
just
different
changing
type
it.
of mass that you're using.
If you
just
if,
said-
no. If I take
Manipulating
an
it.
apple,
Right,
I
let's go-
cannot
let's
change
go
the
back.
mass of that apple unless
Let's
I
go
lop
back.
half of it
you,
off.
you said gravitational lensing, yeah?
Yeah.
And I asked what caused it, and you said mass. If
No,
mass caused,
mass causes the curvature of space-time, which
Yeah.
then affects how light travels. Because and then you
Okay.
use that using.
right. So how did we prove that in experiments in gravitational lensing?
They build on. But that's one of the things where
The
they.
answer is it. Nobody did
No,
anything.
there's one. That's where there's a. It's not a clear-cut answer because it's not. Science.
Adhering to scientific
No.
method.
Science isn't just one thing. You can't look at one
Science
thing.
is a method.
What they did is they took quantum mechanics, they took regular mechanics, they put all of them together into
Come out with a mathematical
into
formula.
big equations
Yeah.
that might
And then
work.
they made
I
an
don't
observation,
know.
yeah?
And then they observed it,
Right.
and it adhered to the maths.
So
and
we've
they
got a
went,
phenomena. We've got
fine.
your first step. We've got the phenomena, gravitational lensing, right?
Yeah.
So to prove that the phenomena is being caused by your presumed cause, in your case mass, we're going to do something where we
Mass's
manipulate the
effect on
mass.
space-time.
We're going to do something to manipulate that mass to prove that the thing that we're looking at, the gravitational
Not to
lensing,
prove,
is
to see whether it works. Because you're
so
jumping
you're saying
steps as well
correlate
now.
is science.
No.
Yeah,
You don't
are.
correlate, because correlate is...
So you've got to experiment. You can't
Yeah.
correlate, you have to experiment. So what was the experiment that
But
somebody
then,
did
but then you
to
do
prove gravitational
but then
lensing?
gravitational lensing is more a theoretical side, which because it cannot be. The thing is,
There's a
so
better
much of
word for it.
science
There's
that
a better
cannot-
word for
if
that.
you
It's
say
called
pseudoscience-
fake science. It's observing a phenomenon
It's
and
not.
not knowing what's causing
It's
it.
not. It's just admitting that you may not know it for certain.
Right? No, it's admitting that you
But
can't
nothing
manipulate it to prove a cause and effect
No,
relationship.
it's proving that you cannot know anything that big for certain until we get out there and actually look at it.
Gravitational lensing does not have any experimental application to comply with scientific method, but you think it's science.
But
And
that's
I'm
because-
telling you
no,
it's
you're
not.
taking scientific method as just
I don't think
doing
it's too
experiments.
convenient, the fact that
There's
all
so
these
much.
observations line up with the maths.
Yeah, correlations, you can calculate correlations.
But you
to
don't think
anything.
it's so
But
convenient
it's
that
not-
over
it's not
hundreds and
just
hundreds and
doing
hundreds
one
and
thing.
hundreds and hundreds and
Listen,
hundreds of
listen,
years, scientists proving
99%.
the same thing over and over and over again.
99% of all motor vehicle accidents are caused by people that believe that we live on a spinning ball. Does that mean that people believe that we... It's true. There's not many flat earthers are out there, is there?
Wait,
99% of all motor vehicle
But that's
accidents
not a
are...
scientific correlation.
No, that's
Because
not reckless
you've
driving.
But you're
No,
correlating...
what I'm saying is there is a process that you have to follow. What you're
Yeah,
saying,
it's called
you're
scientific
just
method.
jumping to one thing. What
I'm not.
saying
I'm going
is-
through the stages
what I'm
one
saying
by
is
one.
You observe it, you theorize
All
it.
right,
you
so
draw
if we
formulas.
observe, right?
But then you may
Let's
not
do it.
get. You may
Let's
not
do it.
get to the point
Let's
where
do it. Let's go through it. So we observe something we're going to call gravitational lenses, right?
Yes.
What's the hypothesis?
the
Mass causes.
the amount of mass of an object can warp its space-time, which then looking at something over a great distance means that you effectively bend space, you bend
Great.
light around objects.
What's the independent variable?
Probably technically in this case your independent variable would be the mass of the object observed.
Great.
Because you would then use that to calculate the degree of warpage of
Okay.
space-time.
I'll accept that. And how did you prove that the cause of gravitational lensing was caused by mass?
By using quantum mechanics and observable physics.
Yeah, that's not how you prove it in a scientific experiment, is
But
it?
then also, some
You don't
things
prove
haven't...
science with science. That's what you're saying.
What?
You don't.
No, you
Using
do-
science to it doesn't prove a scientific
No, we do
concept.
prove things in science. You said before we don't prove things in science. That's not true. We do.
I never said they don't prove things
Yeah,
in
you did.
science.
What do you think the Cavendish experiment proves?
Nothing.
Nothing.
No.
Okay.
No
why-
experiment proves anything.
What was the Cavendish?
There's nothing. No experiment ever definitively proves anything. What it does is it provides more evidence.
No, you
Using
do-
science to it doesn't prove a scientific
No, we do
concept.
prove things in science. You said before we don't prove things in science. That's not true. We do.
I never said they don't prove things
Yeah,
in
you did.
science.
You can prove things to a
It's
certain
literally
degree.
recorded on there. I picked you up on it. We do prove things in science. I said we either prove your alternative hypothesis or you prove your null hypothesis. So we do prove one of them to be true.
No,
and
but
you
just
disagreed.
because you prove something that okay, so if
At
you
that
prove a
time, it was
null
proved to be
hypothesis, or
Right,
you
so let's
prove
go-
one hypothesis, doesn't
Go with
mean that you
water.
proved
Let's
this
go with
one.
water boiling at 100 degrees Celsius at atmospheric
Okay.
pressure at the sea, right? That's never ever going to change. Do you agree? That is a scientific fact.
in a
Distilled
certain
water,
atmosphere.
yeah.
Yeah,
And
distilled
we-
water at certain
Distilled
at
water,
certain
yeah.
pressures.
And we've proved that that is the boiling point of water. That's where we get our scale from, the boiling point of water. That's never going to be disproved by anybody ever, 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 ever. It is proved by science.
Honestly, probability, no, but
proved
there
by
is
maths.
probability of anything can happen. If
But,
you
it's
go
not
into
proved,
that
but, under,
stuff
no,
of it.
but the problem is it's not proved by science, it's
What's
proved
the
by
pro-
maths.
Yeah, but what's how remote is the possibility of something else ever changing to change the boiling point of water?
None, because it's proved
Right.
by maths.
So it's proved. No, it's proved by science.
It's not, it's proved by maths. It is because you look
All
at the
science
kinetic
is
energy.
maths. If you
Right.
really
You
go
look
into
at the
that,
kinetic
all
energy.
science is written by maths.
Science is the process, the observation and the study of the natural world through observation and
The
experiment.
natural world
It doesn't
is
say maths. It does not
is
say
the
maths.
language
Okay,
of
what's the
everything.
definition of maths?
Expression by numbers.
It isn't. Because what about E equals MC squared? None of them are numbers.
So what? It's still.
They're constants.
Yeah, but my point
Well,
is
they're not
that
all constants.
my point is that I agree with you that you can
the reason-
describe the effects of a phenomenon
You
mathematically.
would prove that water boils at 100.
That's the thing, you
at
don't have
100
to
degrees by
observe
using
that.
maths,
Yeah.
because there's maths.
You do have to observe
There's
it.
You
maths.
You do because that's
No,
your
if
first
I've
stage.
never observed the temperature at which water boils at, I could in turn
I've
myself
never sat there
calculate
with a
that.
kettle with a thermometer in it waiting
Well,
to
if
get
you
to
don't
100.
observe a phenomena, then you're not complying with the first stage of scientific method. But you're claiming science.
No, but what I'm claiming is the fact that you don't have to observe something to be able to calculate it.
Yes, you do.
But you don't, because I could.
have to observe a
Because if I
phenomenon.
was to say,
Oh,
like,
no,
I
you
do,
need-
right,
no,
okay,
you can
so
do a
I'm the
ma-
first
you can
person
use
who wants to know how much
quantum to
water
predict
boils
when-
at.
Yeah.
I first
I
want to
agree.
do that.
But
I
in
don't
sci-
have a temp, I don't have a thermometer. What
But
I
in
can do
scientific
is sit there
method,
and calculate.
in scientific method, you must observe a phenomenon because it's a dependent variable. Do you agree?
No, because you don't have to observe it to be able to calculate it. People think
No,
about
that's
think
not what I said.
concepts.
That's not what I said. In scientific method, you have to observe a phenomena because your phenomena is your dependent variable.
You don't have to observe it.
It's your first stage of your
You don't have to
scientific
observe
method.
it. You don't have to observe
That's
it.
bullshit. You're wrong.
But it's not, because I'm giving you an example.
Go on,
I-
then. Right.
Water boiling.
So-
I've never
so
sat there
right.
and observed.
So
Like, sat there and looked at
you've
water
got a
boiling.
degree in quantum physics.
No, but you're not letting me finish my point. What you are doing consistently in this argument is that we start to make a good point and you just go, no, you don't know this. No, you don't know
I've
that.
listened to everything you've
No,
said
you
and I've
haven't.
counted
talked
everything
over,
you've said.
No, you've talked over me quite consistently, actually.
Because you don't understand scientific method.
No,
It's
because I'm
literally
trying to
her
make an
degree.
argument.
She, like,
I think I'd probably. What's your degree in?
Well, given
No,
that,
no,
what's your degree?
given that I'm arguing,
What's your degree in?
Hang
Talk
on,
to
hang
her
on.
about having a degree and a master's. What's
it in?
Just bear with me. Given that I'm battering back everything that you say to me, what would you logically infer, mathematically calculate?
No,
what
what?
do
You,
think my
you don't
degree's in?
batter anything back to me because every time I've asked you several questions, just like this one. What was your degree in? No, don't want to answer that question because it would actually prove the fact that I know more about scientific.
Well, you don't even know the first stage of scientific method, and you claim you've got a degree in quantum mechanics, and I say
Well, I
that's
probably
bullshit.
do know more considering I have a dissertation
What's the
in
first
science.
stage in scientific method? And you're
How
saying
many,
it's-
how many scientific papers do you have out? I have 2. How many do you have? That have been
Answer
published
my
by the
question
Bristol
first.
Society of
Answer-
Chemistry?
answer
I
my
think I
question.
know
Still
more
haven't
about
answered our
that.
question.
I will. I'll come to it. Answer my question
why-
first.
why-
and I'll
why
answer
in a
yours.
minute?
Why is it that you can't tell me the first stage of scientific method?
I do know the science because there isn't
First
a
stage.
definitive first stage scientific method.
So you
scientific
disagree?
method is abstract concept of just like I want to
So
know
you
what this.
disagree that observing a phenomenon
You
is
don't have to observe it.
right? So what do you have to
Questioning
do? Question it. Yeah,
Question of phenomenon.
question a phenomenon. So
don't have
how
to
do you
physically
question
see
a
it.
phenomenon if you don't observe it?
Okay, so I've never personally seen a star die. Never personally seen it, but I want to go. Oh, I wonder if those stars died.
Right.
Or is stars real or alive?
All right.
Never seen that myself, but
All right, but you have seen
could
stars.
calculate it.
So you have seen stars. So you do have the phenomenon of things twinkling in the sky.
Okay, I've never seen a neutrino.
The neutrino. Right. Let's go with an
Never seen.
atom. Let's go with an atom. You've not seen an atom.
Yeah, I have under an SEM.
You have.
Really? You've
Yeah,
seen an
because
atom?
of
You've seen
electronic
electron
microscopes.
Well, as far as I'm aware, nobody has ever seen an atom. We believe that
just-
we see how it interacts.
No, you've never seen an electron. You've been able to see the mass of an atom for hundreds of years now. Evidently, Rutherford's experiments.
So what you're saying is
Use
that
electron microscopes to
To
fuse
see
atoms.
so the-
you can't see electron orbits. That's what you can't see. It's different.
so you can see an atom.
You can
Yes.
see the mass of protons and neutrons collected together.
Yeah.
Can you see an atom?
Yes.
You've seen it yourself.
Yeah.
Yes.
Through an electron microscope.
Yes.
As far as I'm aware, and I might be wrong on this, because science is not, physics is not my area, but as far as I'm aware, nobody's ever seen an atom before.
Well, that's a load of bollocks. This is a. Oh, I can take you up to the University of Liverpool right now and show you one.
Okay.
If you wanted.
So to answer the original questions, what was the first question you asked?
What is your degree in?
I did my degree in straight law, and I specialise in evidence.
So, okay, evidence. So, would you not agree that social science and the way evidence goes along in a social construct is completely different to science because yours is an arts degree, I see you have a Bachelor's of Art.
No, it's LLB, it's not a Bachelor of Art at all.
What is it then?
LLB.
What's an LLB stand for?
Straight law.
Okay, so
It's
mine's
not-
a
it's not
Bachelor of Science, so I think I'd rather know more about how to conduct a scientific experiment than you will, 'cause I presume I've conducted many more scientific
you don't
experiments
think-
than you have.
you don't-
No, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable.
I don't think the first stage of scientific method involves observing a natural phenomenon, and it's
No.
literally everywhere you look.
No, because Einstein's theory of relativity, he didn't observe relativity. He didn't observe this level of, because you can't see on a quantum scale. So how did he think of the concept of quantum
That's
mechanics?
why.
you can't observe it.
That's why
He thought
Einstein.
about it.
That's why Einstein's a theoretical physicist, and theoretical physics without.
That came out to be
Hang on.
proven in practical experiments.
No, it's never been proven. Give me one example where
But
Einstein.
didn't you just say that like quantum mechanics has overtaken Newtonian mechanics in the modern physical world?
According
And if
to
it had
Feynman-
taken
according
over,
to
then it
Feynman-
must have been proven
No,
to some extent.
according to Feynman, it replaced Newtonian's principle, Newtonian mechanics because it
Only
proved that
in
he
one
was
area.
wrong.
Only in one area.
Yeah,
Did
the,
it surpass
the
it?
main area that he
No,
was
no, no,
from.
because there are so many different ways that gravity can interact with things,
Right.
and the
You
way
can't
it acts.
observe gravity.
You can't just
So
say
back
the
to-
idea
back
of
to
gravity
Einstein.
has changed.
Einstein's theories was based on his own theories in his mind. They were a mental construct that he
That you
formulated in
proved
maths.
with physical experiments.
Name one.
that
We've
he
already
did
had
himself.
gravitational lensing. Yeah, but name one. We've had gravitational lensing and there
I
was
can't
no
even want to name
manipulation.
themselves. Just go down to CERN. Every one of those
CERN,
experiments.
right, so what's...
Higgs boson. The formation of how we found Higgs boson was based on Einstein's theory of relativity, which is a proven thing.
No, it's not. It's a mathematical construct. It's
Okay,
theory of
so-
relativity. It's maths.
But it's written in maths, and that maths has not yet been disproved.
Maths is conceptual, right? By nature, it doesn't
No,
exist.
it's not. No, maths is
hasn't
a
been
fundamental
disproved.
language.
What?
Has
Maths,
been
no, hold
disproved.
on.
not
Maths
been
is not a
disproved.
concept. Maths is a fundamental language.
Concept, yeah,
No,
concept.
it's not a concept. It's a fundamental
Language.
existence.
Language.
It's a
It's
fundamental
recognized
language which everything in the universe abides by.
Well,
It's that simple.
everything in the
We
universe
just-
can correlate to
We
it.
just no, it all abides by it. We just have to find what the
formula
different
is.
things are.
Yeah, I agree with that, but that doesn't prove that it's the cause of the effect that we believe we're looking at. Einstein's gravitational lensing, we just established that the cause was supposed to be mass, but nobody was able to manipulate it. So what we did was we correlated what we perceived, and we said we can calculate this, so therefore this is what it is.
But effectively, what you can say is the cause of everything, which you can almost prove through maths, but not quite because it's so long ago. That the cause of everything is this Big Bang, which then set in motion all the fundamental forces, all the interactions,
All right, so
and
the
laid
first-
out maths. And
so
so
the first-
everything now
all
is
right.
just an overshot
All
of
right,
that.
the Big Bang. Do you agree that the first law of thermodynamics states that energy can neither be destroyed nor created?
Now this is the thing, because in the Big Bang, we don't know what came before.
So we have
So no. So this again, it's not proving. I'm just saying that.
Yeah, but the point is,
What
there's
it-
a Big Bang that you accept is why we're here, right? In essence, that's what you're saying.
My belief.
How
yes.
did that energy create? Where did that energy come from when energy can neither be created nor destroyed? But there was a Big Bang, and all of a sudden, over a long period of time, energy was there, but it wasn't there before because it didn't bang.
But it wasn't
So
stored
how
in
did the
the-
energy?
But that's a theory.
Do you
but then
understand
there's
about the
one
theory of the
the-
Big Bang theory?
In which? It's
there's
a very
a-
big
Stephen
topic.
Hawking's.
Yes, I understand generally.
Yes, so you understand the fact that it did start with a singularity.
It did start with.
It started with a
That's
singularity
the
which
claim.
contained.
That's the claim, yeah.
Yes, so
contained
you
everything.
just asked, like, where did this energy come from? It came from the singularity.
The singularity is the idea, but also but then people have theorised a lot of ideas that a little bit. But then it's also like there's also a theory that there was the Big Crunch, which led to the Big Bang. And so,
Which
and
was
so
then- which
no,
was
exactly.
mathematics.
But that sort of stuff will always remain theoretical,
theoretical, yeah. And
because
Einstein's
you
theoretical.
can't necessarily prove it because we don't have the maths.
Right, so let's go back to gravity.
But
What
we
is
don't
gravity?
have the maths to prove the Big Bang, whereas we do have maths to
No,
prove
maths
how
doesn't prove the
stuff-
Big Bang. What proves the Big
No, I
Bang is
just
the
said
Big
that.
Bang.
I just said that. I said that maths can't prove stuff that happened on that magnitude that long ago because at that point, the forces of, as we would say, the laws of nature didn't necessarily apply because you didn't have.
Let's bring
the
this back down to
fundamental
earth.
forces.
Let's bring this back down.
But
What's gravity?
Yeah, but can I ask a question?
Yeah,
Why don't you believe in gravity?
because it can't be demonstrated to be true. We can't even
but we
define
have
it.
the maths.
But what you
So
described,
I
what
can
you
give you the maths
described,
for I can give you the maths for how much wind would be
using
needed for that thing to fall.
observations, though.
Yeah,
No, but,
do it.
no, but that's the thing. That's what I'm saying.
Gravity.
There you go. And then if we used maths
Right,
to
so-
explain that, it would work.
So when he drops that,
Yeah.
you're saying that the cause of that was gravity, yeah?
Yes, the
What-
force acting on that was gravity.
Why do you dismiss the fact that it's heavier than the medium it's in?
Because because when you look at the maths, everything relates together.
The maths, right? But he's just dropped that, right?
Yeah,
But
because
maths
if you
doesn't
say-
prove
no.
that what's causing that to go down. It just
No,
gives
no,
you-
Okay, so then
Because
why
what you
did
do,
things float
no,
in a
hold on,
vacuum?
may I? Because the
Why
thing-
do things float in the vacuum?
Yeah, because
Hold on, hold on. Well, can I tackle this point first? Because we've got this has a fixed mass, fixed volume. Agreed? That means it has a fixed density.
Correct.
So now, when you apply this to maths, you know there are certain constants with this that are just never changing. Now, if I drop this, it's going to fall at a certain speed. That will,
9.8 meters per
that,
second.
that will then stay constant.
So
right?
but that's in a vacuum, though, right? No, it's not constant. It's medium dependent. Because if you drop that in water, it's
No,
not.
I never set a number on it. I just said it will
You said it
fall
was
at a
constant.
con-
No, it doesn't know.
Constant
It will
rate.
fall at a constant rate. No, it will.
No,
yeah.
constant rate is different to a constant speed. You're misunderstanding.
Yeah.
A constant rate
It's
is going to
medium-
fall
no,
at
no,
a
I understand.
constant rate,
No, no, if
whether
I
it's like
drop
this
this,
or whether
it
it's
will
like
fall
this.
at whatever it is, because it
It will
bring
only
in fluid.
fall at that rate in a vacuum
No, no,
chamber.
but I'm not saying it will fall at 9 point. I'm not saying it will fall at terminal velocity. I'm just saying it will fall at a rate
Yeah.
that will be constant every time I drop it because of
Whether you
fluid
drop it in
dynamics,
water there.
because of all these different externals that aren't changing.
Yeah.
Now, so then when you start applying that to the maths, and then you look at F equals ma, we know that for whatever reason,
The
the fluid dynamics and everything, it's falling at the same acceleration every time I drop it from
And
the same
what is
height.
the little g? What is that?
That's no, because in F equals ma, there is no g.
F equals ma. What's
Yeah.
the acceleration in that?
No, this is what I'm telling you. So effectively, when you look at the mass, F equals ma, the mass we've discussed is constant. The acceleration rate, every time I drop it from this height, that's falling towards the ground with exactly the same acceleration rate.
Okay.
So then we look at the F, and you go, what force? What is making that drop? Well,
That's
then
my
if,
question.
But then if you look at F equals mg, is that right? F equals mgh, then the height I'm dropping it isn't changing, so that's a constant. We can get rid of that. Mass we've already discussed is a constant, so that doesn't matter. So now you have F equals g. And then you go, well, what the hell is this other thing, this g, that we've come up with? Because you're suddenly realising, because when they did the maths originally, they would have done mass times height, or height divided by mass, and we've done all these experiments to try and figure out what is the observation
That line I'll
behind
come
all
back
of
to.
this.
That line you just said, I'll come back to.
Okay, and again, I could drop this and go, why isn't my maths showing this? Because the maths wouldn't work without this g constant. So now we've figured out F equals, what was I saying? F equals g. As we've realised that you now have an equation which, when you cancel everything out, g equals a. I don't now sit and go, oh shit, what the hell? And when you cancel the maths down, you realise that you have this constant value that isn't changing. And that is gravity.
Right.
And then you can apply that to everything.
let's go
and
back.
you realise that the reason shit bolts is because of G.
Right, so I'll listen to everything you said and I'll wait patiently for you to finish.
Okay, yeah.
You said in the middle of that, there's a load of experiments that have been done to
Yes.
prove something. That something is what I want to ask. What is gravity? Let's define it before we start talking about proofs. What is gravity?
It's the pull on. It's effectively the effect on mass which pulls it in a certain direction, which is also related. It's not something that's so easy to define.
Right.
Because it
You
applies.
think you can prove it though, right? And we're struggling with a
Because you
definition.
prove it with maths.
No, you don't prove it with maths. For God's sake, man, stop
I
saying
just
that.
did. I just used all the maths and I cancelled it down, and you found that
Explain
there
an
is a
observation
constant that
for me.
exists.
An observation.
Yeah,
an observation for me.
Something that you
If
perceive
I
with your
was
senses.
no, okay, no, I'm giving you an observation for something. If you were to, so how can you explain the fact that if you were to start directly next to the pyramids, for example, something of much heavier mass than you, why does time slow down?
I didn't hear the second bit. You stood next to the pyramid of what?
So something that's much greater density, much greater weight
Yeah, a
than
mountain
you.
or a pyramid, yeah.
Yeah. Why does time slow down?
Why does you're applying Einsteinian? Einsteinian gravity
But
stays.
why?
But
why does it
Lorentz,
though?
are you on a Lorentz contraction? It doesn't actually do it. That's explained mathematically, but not evidently in real
No,
world.
but it has been. So you can go hold.
So give me an
right
example
near the
where
clock.
Lorentz, give me an example where Lorentz contraction has been demonstrated to be true. Not maths, real world. So let's go out of theoretical physics into real world. Because this is the distinction between real science and pseudoscience. Lorentz contraction isn't real. Einstein defines. Let me ask you this.
I might be able to come up with what's the Lorentz contraction again?
It's the thing where essentially because the weight gravity pulls down that space time level. So basically it contracts time.
Right.
So
okay.
further to your question about what you just said about
No, but I
time.
want your explanation as to how do you explain that observation that if you do go stand there with a scientifically controlled clock of something that just bouncing back and forth at a regular amount of time, why does that begin to slow down?
So are you asking me time dilation? Are you asking me to explain time dilation?
I'm asking you to explain what I just asked. Don't put words in my mouth. What have I just
I'm
asked?
trying to get to what you're
So
asking
my
me.
thing is, you can get. I've forgotten the name of the clock. So there's a certain type of scientific clock where it's not measured on a time, like a time scale that would have the
Yeah,
atomic
the
clock.
atomic
Just the atomic clock.
Yeah, so you're
And you
asking.
to take that next to like something of greater density than what you
Right.
personally are, and it will slow down.
Okay, so-
by fractions
so
of milliseconds. What?
How do you know that it slows down?
Because it's been observed.
Pardon?
Because it's been observed to
Because
slow
you look
down.
at it.
It's
and
been
you
observed,
observe it.
right?
Yeah.
So that means
So
it's
you
been
know-
measured. Right,
No.
do you know what the rate of time slowing down is in this context?
Fractions of seconds.
It's much less than that. There is a Einstein quantified it.
It's a fraction of a second, but that's
George
What
Musso,
did you
George,
quantify it with?
But it's
George, a ratio.
regardless of the
No,
fact
hang on,
whether
it's important. It's important because scale's important in your question. You're asking me how did they measure time dilation and
No,
how do
no,
I
I'm
explain
not
it?
asking that. I'm asking
You're asking me
how
to
do you explain it? Yeah.
Right, I'm getting to it. I need to know that we have a valid scientifically observed phenomenon.
Yeah.
And my question to that is, how do you know that time dilates? And I will cite back to you George Musa, writing for Scientific American, who states that Albert Einstein said that down is the direction in which time travels more slowly. That's what Einstein says. He quantifies down and time travelling more slowly to be parts in a trillion. Now I'm asking, how do you know that time dilates if the scale is parts in a trillion? And I will say to you
It doesn't
that it's
dilate
never...
by parts in a trillion. You can visibly see it by fractions of a second.
George Musa writing this scientific... I can get it on my phone right
scientist.
now. No, he's an astrophysicist with a PhD.
But you said astrology wasn't real. If you astrology wasn't real science, so how's an astrophysicist a real scientist?
I'm not saying I agree with him. I'm answering your
But
question.
no, you're
with-
not, because you're giving his answer.
Yeah,
and then, but
I'm
that's
using
not
him to
you
answer.
answering it. But then you're saying
My
you don't
answer
believe
is
him.
time doesn't dilate.
But then
Because you
It
can't
does.
prove that it does. It doesn't. There's
you
parts
can
in a
see it.
trillion, and there isn't anything that we've got on Earth over the
Not
time
parts
that
in
we
a
need.
trillion. Well, you also just said that
Right,
you
do
didn't
I need
agree
to
with
prove
him.
it? Do I need to
But
prove
you
that he
said
says?
that's what he said, but you then also said that you don't agree with him.
I'm using your science against you to demonstrate that time doesn't dilate.
No, explain that. You just said...
It doesn't.
But
Time doesn't dilate.
how do you use our science against
Do you
us?
get
Like,
what
what
he's...
would-
how he
what would
just said that he-
Time doesn't dilate. Your
kind
claim
of.
is that time
No.
dilates. I'm saying
No,
it
no,
doesn't.
I didn't claim that at all, actually. What I
You
said
asked
was,
me to
how do you
explain.
explain this observation? That
Yeah.
wasn't me saying
And
I
my
agree with
answer
that.
is- my short
you
answer-
put words into people's mouths. You
No,
need to.
my answer
we're
to your
saying
question
we've
is that time
observed
doesn't
it.
dilate.
But
Okay.
we've
And my,
observed it doing
my
it, so then
authority,
how would you prove
hang on,
otherwise?
my authority for that is George Musa writing in Scientific
did say
America,
that it dilates
who
by
said that
trillions and
Einstein's
such.
parts in a trillion, yeah. And
But
I'm
it
gonna
does
say-
dilate, though. Because
Right.
it dilates by
So
parts
where's
in a trillion.
where's
It
the
does
ev-
dilate.
where's the evidence that time dilates if it's
Well, you
parts?
just said that scientist guy that you just said.
Where's the evidence that time dilates
That
if
guy
it's
would have
parts?
had it.
Well, listen. Where's the evidence that time dilates if it's measured in parts in a trillion?
Well, look at the
Maths.
George
It doesn't
Musa.
exist. Yeah,
no,
maths.
no, hold on. Look at the rest of what George Musa says. If he's saying that it occurs, he will
Then it
he will
occurs.
cite it somewhere.
And you
You're
should provide the
effectively,
evidence.
I'll read to you what he
you're
says.
effectively
I'm trying to
saying
get at
that
the point.
it can't happen because this guy says it happens really small. But that's still saying it's
It
happening.
happens.
It's just saying that it's happening on a really small level.
I'm not saying. Listen, my answer is time doesn't dilate.
But then you've
So you
cited a
can't
guy
use-
who has said that it is
to
back you
quantify the
up.
scale. Yeah, to quantify
To
the
say
scale.
that-
No, not to back me
No,
up.
no, it's
no,
not-
no,
it's
not
not
to,
a
no, no, no,
demonstration.
no, let me correct you. Not to back me up. To quantify the remoteness of the claim that you're making.
But if he said that it
I
happens,
need to explain it, and I
it
have
doesn't matter the scale. He's saying it
does, it
happens.
really
No,
matters.
it doesn't.
It
Because
does.
he's saying
Whether
it
it happens
happens
or
on a
not.
tiny scale.
No.
But it happens. That is the crucial bit of
No.
what he is saying. And then you
Einstein
said,
said
I'm
it was
using this-
parts in a trillion, and I call bullshit because we can't measure parts in a
No, you
trillion.
said Musa said that it does happen by parts in a trillion.
Right, Musa was quoting Einstein, who said that it was parts in a
But what
trillion.
did he say about it?
Einstein, parts in a
No,
trillion.
Musa.
I'm going to get to
Did
you.
he
I'll
did
get to you
he
now.
disprove it, or did he prove that it happens
No, he
on a
didn't
very
disprove
minute
it.
scale?
He didn't disprove it. He tried to he was explaining down in the context of gravity. Down is the direction in which time travels more slow. Down is slow time. The question I was asked was, how do I explain time dilation? My answer is, because it's too remote, it can't be proven to be true. That's the answer. But because it's quantified to be parts in a trillion doesn't make it true. What makes it true is demonstrating that time dilates. And I said it can't be.
The atomic clock.
That's the claim. I want to see the evidence that that's actually true.
Read that
How-
guide that you wanted to
No,
say.
no, you're not. No, because what you're saying
How
is
do
you want to
right,
observe
the-
it,
the
whether
atomic
it's
clock-
true.
Like, listen, the atomic clock is basically a measuring device. So you've got two of
Yes.
them next to each other, and you're looking for the differential between the two. Read what it actually says about it. It would take millions of years to get a nanosecond out of it. How the hell are we going to do that other than calculate it with maths?
What do you mean
But
to get
it
a
says it
nanosecond?
would.
There's not enough time for us to ever observe or measure it. They just theorise that
What
it
do you mean?
exists.
To measure what?
Time dilation.
Yeah, but how is
But
it?
they've observed it.
No,
Yeah,
we
they-
haven't.
they
They just
theorised
said that it had by a trillion, yes, but just because it wasn't observed by a nano, you were like disregarding it completely.
because there's no
Oh,
evidence that
it's
it's
because
true.
but there is.
No.
The guy you're citing is saying that there is evidence
No,
to
he's
support
claiming
this.
it's true. Doesn't make it true. You can claim you drive a Ferrari, but unless you show me the Ferrari, you're not got a car, have you? Just claiming it doesn't mean that it's true.
So what's the point of any scientist making any point claim if they can't prove it?
The
Because
point of
there's
this-
enough
The
evidence
idea
to
that
back
time
them up.
passes slower the more you move is called time dilation and has been empirically proven through countless experiments.
Name one.
Okay, let me load the article. Oh God, where are you going?
I bet you what they call experiments fail to comply with scientific method, and they will be
Which one?
pseudoscience.
Which one though?
The one that gives you a cause and effect relationship
But
with
there
a
are so
valid
many. But
hypothesis.
scientific method is about 8, 9, 10, a billion different steps.
It's not.
It
there's,
is.
There's a couple of core principles. You've
No,
got
it's
to
not.
It is.
It's observation.
Oh,
It's measuring. It's retrying.
What you're
it's
doing,
trying maths.
you're
experiments.
stretching the boundaries of scientific method to
No, I'm
accommodate
not.
pseudoscience.
I'm not.
He's actually making it the basics.
I'm the basics.
But I'm telling you that you've got the basics wrong because you've got to
I'm
have a
saying
valid
you're too
hypothesis,
basic, though.
a valid independent variable, a valid dependent variable,
any-
and you've got to
That's
manipulate.
not
So any
scientific
experiment-
method.
it
That's
is.
that's part of
It's
trying to
scientific method.
quantify and trying to experiment with stuff.
What's your degree in?
History, but I did physics and maths A.
Right, and so you're arguing with me on scientific method, and you're
He's
quiet.
no more qualified than you are, though. You did law.
Right, but you're quiet in this area that you expertise in.
Yes,
and I'm
because
sound
wondering-
louder.
honestly, yeah, one, he's louder. Two, I know he's better at making an argument than I am. Three, also the fact that half the shit that's coming out your mouth is absolute bollocks. It makes no sense because you're constantly going back and forth on yourself. Three, for the fact that you clearly don't understand basic science because you've never done a fucking science experiment in your life.
That's not true.
When was the last time you did a science experiment?
I demonstrated
No.
I-
When was the last time you did a science experiment?
2 months ago.
On what?
I demonstrated that I could manipulate the density of a medium and cause an object to accelerate.
How'd you do that?
I had a pint glass full of water, I had an egg, and the egg sank to the floor. I added mass to the water in the form of salt, and basically I got the egg to lift off the floor. And when it got to that...
Congratulations, you can do an science experiment that probably a 12-year-old could.
Yeah, well you didn't ask me to do an experiment that wasn't of a 12-year-old. You asked me how
Okay.
long ago was it that I lasted an experiment.
Okay,
and my
when was
answer
the
was
last time you
2
did
months
a
ago.
when did you
And
last
now
do
you
a publishable
ridicule it.
experiment?
I don't have to publish it to perform science.
When was the last time you did a publishable experiment that was recognised by a scientific committee and board?
I can't
When was the last
publish
time
it.
you did that?
I can't. When was the last time you did?
Like 2 years ago? Last
Right,
year?
and where can I
Actually,
find it?
5 months ago.
5 months ago. Where can I find it?
Royal Society of Chemistry.
Right, and what did you prove?
Nothing that you'd actually understand.
What was your hypothesis?
Hypothesis was based upon a forming material.
What?
It was forming a material for a science company.
Forming a material.
Yes,
And what
sir.
was your independent variable?
Independent variable was the amount of iron oxide, I believe that was in it, to increase or decrease the heat capacity of the certain material.
So what you're saying is the amount of iron oxide in your thing, your experiment,
Change the heat capacity of the material.
and that caused something to form. That
The
created
whether
a
it
material.
going to crystalline or a little not.
So back to the hypothesis. What was your hypothesis? That if I did what?
If I manipulate the amount of iron oxide, it will change the heat capacity of a certain material.
Right. So why can't you formulate that, what you've just done in chemistry, in the context of time dilation or
Because they did.
lensing, gravitational
In
lensing?
1971.
You've done.
No, here.
You've done something where you've
You
manipulated
were talking about
the force.
which experiments they did. In 1971, Hafele, I don't know, and Keating flew cesium beam atomic clocks initially synchronized at the atomic clock around
It's
the
all right.
world.
It's all right. It's all right.
So what they did is they synchronized these cesium beams with the initial atomic clock. They then fired the
So you're saying that they
particles
synchronized
eastward
it.
and westward.
Yeah, I understand that, but
Yeah.
what you're saying is that they synchronized it, right? And given
Yeah.
that the parts are parts in a trillion for gravitational lensing, according to Einstein, I'm going to ask how you calibrated that to prove that it was synchronized.
Because they would have done measurements on it with
Parts
maths.
in a trillion. Do you understand how
It's
big trillion is? Yeah, calibration in a trillion. That's crazy numbers. Nobody can calibrate anything to parts in a trillion.
Okay,
What,
here you go.
theoretically?
Okay, no, so here you go.
In the real world?
After each
Parts
flight,
in a trillion.
Yeah, but look,
Nonsense.
look at what they did. After each flight, they compared the time on the clocks in the aircraft to the time on the clocks in the observatory. So the fired part.
No way! You're Mr. Chesney. I'm sorry. Just
But this is the experiment. So I think what they did is they synchronized them and then sped them one way, sped them the other. They then brought them back and measured them according to what they think, what the predicted ones are,
what was the
and it
result?
matched every single time.
what's the results?
Yeah, but
Oh, right, okay. So what's the results when it's parts in a trillion and you need a lot of time for them to pass? For it to pass.
No, you don't wait for it to pass to say get like a second. You measure it using the maths and whether the maths will line up. And every single time they did the experiment, the maths lined up.
All right, what was the name of that experiment?
It was Hafeel
What I'll do
and
is,
Keating.
I've not heard that one before, so what I'll do is I'll put that into my phone, I'll go and research it, but I can guarantee you this, it won't comply with scientific method.
But
it'll
it
be
did.
It'll be deemed theoretical.
It did.
How? I bet you there wasn't. I bet you there
But
wasn't
the
a
thing is, it's what scientific method are you using?
hypothesis testing.
Yeah, no, they did. They said
Right, so
if we fire it that way and fire it that way, the hypothesis is they will be out, but their time will dilate by this much amount based on earlier predictions of what they think it is. That's their hypothesis. They then observed using the.
Give me that name. Give me that name.
It was HAFELE and Keating
Happily Handles.
and Keating.
Keating.
ING.
Haffel and Keating experiment, time dilation.
Yeah.
Right. Let me.
So then- so
I'll be
what-
honest.
no,
I'm
no.
not familiar with that one.
But what
I
they
will
would have
look
done
into
is
it.
they would have observed the difference in time.
Tell you what I'll do. I'll make you an
would have-
offer. I'll make you an offer.
But I'm explaining why they went to scientific method, because they wouldn't have got it published if they didn't.
Given that I've never heard this before, I'm not going to argue from ignorance. Allow me the opportunity to go read the paper, and then I'll invite you to a hangout on YouTube where we can discuss it. Find me on Sleeping Warrior. You can find me on YouTube, and I will go through that with you, and I'll show you the exact point where it becomes pseudoscience, and then we can argue whether it's science or not.
Mark, you are an.
Okay, so this is basically my attempt at researching the point that was being made. So what I'm going to do, I'm going to show you what my researchers discovered in relation to this atomic clock's claim. Now, my claim was that they can't calibrate these clocks to be accurate enough and to pass enough time to be able to calculate time dilation in the first place. My reason for that is cited by George Musa in Scientific American, and if Fight the Flat Earth wants to challenge this, be my guest. George Musa, writing on November the 1st, 2015, in this article, cites Einstein for quantifying the parts per million, the quantity of dilation. And this is, I'll read from it. The morphing of space and time is not just the stuff of exotic physics. It governs the motion of any falling object. Baseballs, wine glasses, expensive smartphones, things that slip out your hand accelerate towards the floor because Earth's mass warps time. The warping of space plays only a minor role in these cases. Down is defined by the direction in which time passes more slowly. Clocks at sea level tick more slowly than clocks on the summit of Denali. I'd love to see the evidence of that being true, but a watch strapped to your ankle will fall behind one on your wrist. Again, I'd love to see that being true. This is pure theoretical physics, in my opinion. Anyway, in human terms, the deviations are small. Let's change the word small to microscopically, infinitely... what's the word I want? Stupidly small. Parts in a trillion at most. But enough to account for the rate of blah blah blah. So the bit I'm really focusing on for the purposes of this discussion, this bit of research, is this parts in a trillion. So parts in a trillion, I wanted to know what is a trillion. I didn't know whether it was 1,000 million or a million or whatever. It's one of those numbers that you never come across. It's got 4 banks of 3, right? A million, 4 banks of 3, and it might even be different in America, because sometimes Americans have a different number for different words. This is just what I'm reading from. So a million, 4 banks of 3. So he quoted this citation. Let's make this a bit bigger. Around the World Clocks. He gave me the name of the paper, and I found out where it was published. And I've got I searched for cesium beam atomic clocks based on the name and stuff. And what I found when I searched for cesium beam atomic clocks, it says it keeps time to a second in 300 years, right? So 1 second in 300 years. So then what I did was, how many seconds are there in a year? So at first I put how many seconds are there in 1 year, in 300 years, and then the number, it didn't work. So I did it in 1 year. How many seconds are there in 1 year? And it says there are that amount of seconds in a year. So what I did was I got that number, copied it, and what I'm looking for here, I'm looking to see how many seconds there are in 300 years. Okay? So let's bring the calculator over. So what we'll do here, that's the number I got. So what we'll do is we'll clear everything, and we'll put in there, we'll put this number, which is the copied number from here. This is the number of seconds in 1 year, and we're going to multiply that by 300 to give us a number. So what we're looking for, let's copy this number. This is a big number. It's one of these numbers that he struggled with. He struggled even saying it correctly, and I'm not even going to try because it's not important. What matters is this greater than, equal to, or less than parts in a trillion? So we know a trillion is 100 million, is a million, right? So, and we know that the amount of seconds in a year, in 300 years is this. So what we're saying is, or what I'm challenging is, are the clocks that he cited accurate enough for the purposes of both calibration and demonstrating time dilation? Because obviously my position is that it's not. But basically, if they are accurate enough, according to the citation here, Navy, US Navy, I guess, it kept time to a second in 300 years. How they know that, I have no idea. But that's the claim, right? Well, parts in a trillion is 4 banks of 3. And that clock gives us that amount of seconds in the claimed amount of time that they are accurate to, 1 second within 300 years. But there's that many seconds in 300 years. So basically, the issue becomes, are they accurate enough to demonstrate the point? So there's a million, 4 banks of 3, and there's only 1, 2, 3 banks of 3. And that means that this clock that they're talking about, this Cosium beam atomic clock, isn't accurate enough to demonstrate the parts in a trillion quantification by Einstein, because it's missing 100. Is it 1,000 million? It's missing. Hang on, how many is it missing? 1, 2. It's missing 1,000 seconds out of it. It's not accurate enough. So it's difficult to explain this, but I'm hoping that you get the point there. So when he says parts in a trillion. And in the paper, it says 4 cesium-based atomic clocks were flown on a regularly scheduled commercial jets around the world twice. Once eastward, once westward. Interesting they didn't go north or south, it went east to west. But anyway, to test Einstein's theory of relativity with macroscopic clocks. From the actual flight paths of each trip, the theory predicts that the flying clocks compared with the reference clocks at the US Naval Observatory should have lost 40 plus or minus 23 nanoseconds. So that means basically it's 20 nanoseconds during the eastward trip, and should have gained 275 plus or minus 21 nanoseconds during the westward trip. The observed time differences are presented in the report that follows this one. Basically, that's what the differential should have been according to this. But according to George Musa in Scientific America, he said it's only parts in a trillion. So it seems to be that it's not accurate enough to maintain that amount of time in 300 years anyway, because it needs to, in 300 years, if it maintained 1 second in 300 years, that when you work out the maths and you work out how accurate that is, it isn't getting the minimum standard of parts in a trillion, because there aren't actually a trillion seconds in 300 years. So it's not accurate enough anyway. So although these mathematics may well be right, and I'm not saying that they're right or wrong, what I'm saying is, if these cesium beam atomic clocks are accurate within 1 second every 300 years, which is the claim, then this nanosecond thing, I mean, this is such an infinitely small amount of time that they're not accurate to within the parameters cited by Musa in this paper in parts in a trillion. So either Musa's got this wrong, because parts in a trillion isn't accurate enough, or the maths in the paper are wrong, but at least either way, both of them are contradicting each other. And the question becomes, even if, I mean, how do you, think about it more on a logical, practical point, how the hell do you manipulate time? What we're looking at here is 4 cesium beam atomic clocks. Now, whether they're digital, analog, or however they work, does not mean that we're manipulating time. We're measuring the time it takes, and then we're using a differential between what they claim is the differential between the two. You can't manipulate time. We've had this before with the independent variable being time. You can't manipulate time. So, and even if you could, let's just say that you are Doc Brown. The difference is incredibly small. It's so ridiculously small that I don't think that any machine measuring time in the first place would ever be accurate enough, because a second in 300 years, by the maths to work it out, doesn't give you that part in a trillion that Einstein claims it's less than. I mean, let's go back to his paper. It says parts in a trillion at most. I don't know how many parts, but it's at most. So we could just basically say it's 1 part in a trillion, but there's not a trillion seconds in 300 years. So it's within a second for 300 years, but the numbers don't add up anyway. Anyway, that's my research on that. So I just wanted to stick this in so that I could show that I have done a little bit of research into this. I'll refine this argument before I speak to him, but in any event, it's not supporting the assertion being made.
You're a celebrity.
Hello, Mark. And
All
most of
Einstein
it gets discredited very quickly. This stuff hasn't. It complies with loads of other experiments that also
Einstein
happen.
stuff is all theoretical physics, all of it, and in general
But the
relativity.
not when you look at gravitational waves. Because that's
Gravitational waves are theoretical physics. We
No, it's
can't
not.
test-
We've seen them.
Yeah, so what? We can't prove what's causing the thing that we believe we're looking at.
No, we did.
No, we didn't.
We did because we looked at black holes and we said, in theory,
Theoretical physics.
no, what they said is our hypothesis is when two black holes merge, this should happen. That's their hypothesis. No,
Black
this
holes.
is what they did. And then they said, well,
How did anybody
I'm-
manipulate a black hole, even if they exist?
No, they didn't. They observed. They just looked. There are people in observatories all the way around the world scanning the heavens constantly, trying to find stuff like this, and they did.
Listen. Let me wrap this up because I want to speak to this guy. He's a little known troll, and it's the first time I met him. But what I'll invite you to do, let me look at that paper, and I will, and then we'll have a conversation. If you look me up on
Just so
YouTube,
much stuff that I'm
It's fake
trying
science.
to prove to you
Right.
follows the same scientific methods you're
So
saying, and
allow
instead
me-
you're just saying,
allow me the
oh,
opportunity.
find
No,
this-
I'm not. I'm saying let me look at the paper and let me work out the bits where they've not complied with it. I'll
they would
tell.
have done.
Yeah, you're assuming that.
Because they're world-renowned physicists. Who are
But
at the top
I'll
of their
show you
game.
that they won't have done if I get a chance
But
to
you're
look
not
at
a
it.
scientist, so you wouldn't
But
know
I
the
know
ins and outs
scientific
of-
method.
How?
It's not
Do you think
because
you
I've learned
can?
it.
But don't you
But
think
learned
it's
it when?
kind of-
What, GCSE? At O level?
Do you think it's kind of
scientific-
ignorant that you think you know more about scientific theory than world-leading scientists?
Than the world-leading
I'm not saying
scientists.
scientific theory. I'm saying scientific method. There's a
Okay,
difference.
the
okay,
theory
same
of
thing.
scientific
Same
method.
question.
Really.
Do you think you're more ignorant to say that you know more about scientific experiments, scientific? Sorry, what's the exact wording that you want?
Theory, you said.
No, what? Not your
Method.
wording. Method.
Scientific
Do you know
method.
more about scientific method than the top leading scientists in the world?
I would
I
never for
know-
a minute say that I know
Let me
more
ask-
about
Yes or
the
no?
legal methods than you do. Because I don't know it. I haven't
Yeah.
studied it.
Exactly.
That's fine. To answer your question, you've got a. Did you say you had a degree in
Chemistry and
quantum physics,
quantum mechanics.
quantum mechanics at degree level? Yeah.
Yes.
But we've demonstrated that you didn't know what a valid independent variable was. You did get there.
No,
in the
you're
end.
absolutely correct. Completely discredit my degree. I'll go hand it back in. No, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable. No, the presumed cause is the dependent variable. You're absolutely correct. This isn't answering my question. What you're doing is you're back and forthing. You're not creating a good argument. You as a lawyer should know that just going like, actually what I'm going to do is just to tear them from a different point. I asked you a basic yes or no question. Do you think you are ignorant for saying that you know more about scientific methods than top leading scientists?
Who have spent the
That's
best
a
who have
yes or
spent
no
their
question.
lives
That's
doing
not
it.
actually going, you don't know anything about science
You're
either yourself.
quoting
I'm
me.
asking you a question.
You're
I've never
quoting
once
me.
said I think I know better than what they do.
You're quoting me for saying that I think that I know more about.
No, I
leading-
didn't quote you.
That's
I
what
asked
just
you a
said.
question.
Right, ask
I
the
said,
question
do
again.
you think?
Yeah.
So that's not quoting you.
No,
that's
no.
asking, do you think
That I
you
am
are
ignorant?
for thinking that you know better?
I didn't
than
say
a
that.
scientific
You're
method?
putting words in my
But
mouth
you
here.
just did you
In
not
your
just say
opinion-
they didn't know how to do scientific methods?
Yeah, because you don't know what they. Right, the first stage is observe
This
and
isn't
natural.
about me. I'm asking you a question about yourself.
Yeah, but you're saying that I think that I'm better qualified than whatever.
no,
it
I'm
was that you
asking,
said.
do you think?
Yeah, but I don't think
Do you-
that. No, the answer
okay,
is no.
so they probably do know how to do scientific methods better than you and
Yeah, but you've got a degree in quantum
I'm
physics.
not asking about me. Stop turning it back on me. That's not
But
the
you're
point of this
turning it on
argument.
me, and you
Because you're the person claiming that you know better.
observe a natural phenomena is always the first step of a scientific
So
experiment.
basically, yes, you think you know better than these lead
Are you saying I'm wrong?
I don't want to be rude. So, observing, no?
Observe a phenomena.
Base it on observation. Why at the pole, North Pole, South Pole, the day have 6 months, the night have 6 months. On the equator, what we know, it is equator, the day have 12 hours, the night have 12 hours. At 45 parallel north and south, the day and the night are variable with 3 minutes approximately from one day to other. For this reason, we have the solstitium, the equinoctium, spring, autumn, equinoctium, and the summer, winter solstice.
Yeah.
That is the reason for why the Earth is spinning,
Right.
and he have the
Is there an
the
the axis?
the axis
Yeah, yeah.
in
Is
that
there
angle.
is there an alternative explanation?
No,
there
there's not.
was initially, and it
Come,
got
come and
disproved.
show me. Show me
No,
on
no,
the map.
no,
You
there
have
was.
the map there with
There
the
was
Earth
an alternative
Earth planet.
explanation, and it was the geocentric solar system method. Which then, when Galileo started being like, nah, I don't think that's right, he was like, shut up for it. And then eventually, people went, actually, his science works. Actually, when you observe it, when you apply it, when you realise that actually it's a heliocentric solar system, suddenly the science and
So-
the maths made sense.
Right. Okay. It may make
In
sense.
the same time.
So
in the
doesn't
same time,
doesn't that
in
explain
the
it? Because
south-
they
hang on.
observed it, they did
Right, there's two things.
experiments
Let
on
me
it.
answer him first.
Okay.
And in the same time, in the south hemisphere, the constellation are very different about the constellation what are in north hemisphere.
Right.
So we can't see the cruise of south. They can't see
We have to be
the
facing different directions.
That's true.
polar
And we do
star.
face different.
But then how do we do that if we're all on one plane facing up? If we're all on a flat Earth facing up, how comes us up here see something completely different up here than they do looking up? Australia,
Right.
the southern
all
northern
right.
hemisphere is
Let me come
completely
back to that in a sec. To answer your question,
That was his
I
question.
asked you, is there an alternative explanation?
But
for
you
the-
haven't.
Okay.
And I said
And
yes.
you explain.
No, and
Yeah.
I said yes.
So-
and I said yes.
Could we
and
go
I
to
explained
maps?
it.
So
To
basically,
be more
if-
argumented
yeah,
at
but
the map.
the alternative explanation is that if the Earth is a plane and there is a close and local sun orbiting
Mm-hmm.
around us, there will be a proximity-based relationship between the sunlight and the person underneath. And if the sun's moving further away and then coming closer, moving further away and coming closer, proximity is the explanation, the alternative explanation, if we're not on a sphere. Now, we may be on a sphere, we may not be, but there are two interpretations, and we don't know which one's true. We believe one, and we reject
Okay.
the other.
Okay, I see what you're saying there. But then we say, but there's also evidence that us on the northern hemisphere can see stuff that is different from the southern hemisphere.
Yeah.
So how does that work if you're on a
Proximity as well.
plane?
So, all right, so
'Cause we're all
your
looking
eye,
up.
would you agree that your eyesight is probably better than
But that's
this
not what
Jen?
I'm saying. I'm saying if everyone here is looking up, how do we see completely different stars and different constellations?
Same proximity is the same answer.
But it's not proximity, because if
Why?
we all look, because if I'm standing here, we can both see the Burger King, right?
Yeah.
Yeah.
Can I see the Burger King?
No,
But why?
because you're now facing that way.
Exactly. So if we're all on a disc and we're all facing up, all facing the same way, I'm Australia now, you're UK. We're on a disc. This is all flat.
So yeah, so you've got Polaris in the middle.
we're facing up.
So let's go with Polaris.
Polaris will be that way.
All right, so Polaris is over here, North Star, yeah.
Yeah.
So right, so
So
you
why-
can see it in wherever England, yeah.
No, see, I'm Australia.
You're in Australia.
Because we're facing the same way.
Right, so let's say you're Australia.
Okay.
Stand there for me. Stand there.
No, he's the UK.
I'm UK.
He's
I'm
the UK.
in the
We're just the opposite sides of the
Okay.
flat Earth.
All right, so you can see Polaris there.
Yeah.
You're too far away to see it.
But there it is.
I can't do scale now. All right, if I was to do the scale,
You can go all the way back to Burger King. I'll still see it. Yeah, it's there.
It's there.
Yes, it's there. I can. No, I can see
That's
it.
just like saying there's a cloud in the way. That doesn't work.
Perspective matrix.
No,
Everything
because
in the
when
sky.
it's night,
thing is, could be
because when it's
perspective.
nighttime and
Could
there's
be
nothing in the
perspective
way.
about
You really
one
wanna
star,
go on
not
to
all.
perspective, then
Yeah,
it's the
could
whole
be the
thing of
best-
that's so
let's see.
far away
Even
that
so.
the pivot, the
Right.
angle at which
So
those
we're
two
getting
are
there, we're
different.
getting
No, because
no,
I'm not
we're
agreeing with
disproving
you.
you.
Because of the fact that you have so far away as Polaris, the angle at which those two are seeing that perspective
It's
becomes
minimal.
so minuscule that you were
Literally
discrediting me for.
basically a straight line.
You can see it.
right.
You can equally see what Polaris.
But the thing is when you're in the south, you can't see it at all. You see something. What I see here is I see Vodafone. I don't
Yeah,
know.
I
I'm
see
seeing-
Burger King.
I'm seeing Southern Cross.
Yeah,
I'm
I
not
see
seeing
McDonald's.
Polaris.
I see
Because we're
Carl's.
facing different
Yeah, I
ways.
see him.
I get your point. If perspective is going to be the way the conversation is going to go, that's fine. But what I'll say is, just because, if I got my headlights on my car and I flashed them, do you think that you'd be able to see my headlights flashing from London?
But there's stuff in the way. Like there's
Exactly,
a building.
exactly.
But the difference is neither of us would be able to see it.
Yeah, but the thing is, when there's a
That's the
plane,
difference.
if there's a
Now
plane,
I can see it from London too.
yeah, but if there's
I
a
can't.
plane, if there's a plane at 30,000 feet and it stays at 30,000 feet continuously as it goes into the distance, it doesn't change its elevation. Do you agree that appears to go down to the horizon from the observer, the perspective of the observer? Yes or no?
Because it's curving, yes, and that is the natural.
So
if
you
you're
don't-
going like that,
So you don't think that the convex shape of your lens on your eye causes everything to focalise in the middle?
no.
Then you don't understand the anatomy of the eye.
I mean, I do.
That's perspective. Your
No, it's
eyes,
not.
your eyes have that shape, and that's
They
what
don't
gives.
make the world do that. What they do is when
course
light
they
is
do,
coming in
because
from.
you
No,
turn
again,
that-
you've got cause and effect the wrong way round. When light comes in from really far away, it bends and focuses in your eye. That's why it's shaped like that. It's not to make the world squished or
No.
bend out.
Everything that you
It
look
doesn't
at
do
right
that.
in front of you, your eyeball, it's the very centre of your eyeball, isn't it? Do you agree? And then from that point, everything's wrapping round. But in our visual acuity, everything focuses on that one point. That's why train lines, even though they're always parallel, they never actually meet. They appear to meet to the perspective of the observer. But when you look at it side on orthographically, they don't meet. Everything
But
meets
that's-
in the middle. That's perspective. It gets
But
smaller.
that's not because my eye is bending it so it does
Yes, it
that.
is.
It's just that's
No,
what
not
it
bending
naturally
it, so-
does.
No, it
But-
doesn't.
but
The
that's
train
also to
lines
do with the
don't meet.
perspective.
The train lines don't meet, do they?
No, I know, but the thing is,
But your
that's-
eyes perceive that they do.
No, they don't. They just perceive
Really?
it. When it gets so far away, your eye cannot just distinguish. It's not telling you that they meet because I know that they don't meet.
Yeah, I know.
What it's saying is that
But
the
it
distance
does-
gets
it does
so
tell you-
minimal.
No, it does tell you that they appear to meet.
No, it just says that the distance becomes so minimal that your eye can no longer distinguish the gap in the middle.
Yeah, but they appear to meet. That's the point. If you get a road and all the traffic going up to the horizon, all the traffic appears to go up in a triangle to the horizon. Appears. But we know it
but
doesn't
that's
do
perspective.
that. Yeah, I know. That's my point. No.
But that's not. But
So-
the, but
so
the
the same
difference,
stri-
but the
the same
difference
string
is,
in the sky.
but the difference is if I'm, it doesn't matter where you are on that plane, you will see the traffic going into the single point.
Yeah, but that's
But
perspective.
what I'm saying is that doesn't prove that we're all on the that would only work if you've got two people facing the road and watching it disappear into a point.
Yeah,
They could be
but with
anywhere
regard to
along that way
Polaris-
facing that way.
but with regard to
What I'm
Polaris-
saying is there are some people who would be facing this way going, right, where's the traffic? I don't know where the
All
traffic
right,
is.
let me
because
deal with
they're
that in a
watching
sec.
a lorry collide with an old woman or
Let me
something.
deal with
I
that
don't
in a sec. I'll come
But
back
they're
to that.
seeing something completely
So
different.
if we stand underneath Polaris at the North Pole and we start moving in any direction away from it, it's going to appear to drop
doesn't.
towards the horizon. It does. For every 69 miles, it drops by 1 degree.
Polaris, it moves.
It appears to move.
It's constant wherever you are.
No, it appears to move
But
because we're
it
moving.
gets close to the horizon because
Yeah, the further
yeah,
you go.
because it's
Because
doing
that's
that.
not that's it itself.
It's
not
effectively
moving,
hiding
you're
behind the
moving,
it's hiding behind the curve.
Effectively hiding behind. Yeah, that's right. So as you move every 69
I just said it's
miles,
hiding behind the curve.
And you disagree
no,
with
no,
that?
no. You said effectively. That was the key
No.
word.
I said
Effectively.
it's hiding behind the curve, and you said
Effectively.
yes. You just said yes to the fact that there's a curve.
Yeah, but your prefix was the word effectively.
But you still agree with the fact that there's a curve.
Even if it's effectively hiding behind the curve because it.
Polaris moves at 1 degree
But if it
every
was
69
flat,
miles.
I could move as far as I wanted, and I could still see it.
Right, listen, the answer to the question about Polaris, right? If you're at the North Pole and you move in 69 miles in any one direction and maintain that course line, Polaris will move by 1 degree in the night sky on the model that we're told.
Okay.
The problem is in real world it doesn't do it. Because in the real world, Mick West is the citation for this, you can look it up. As Polaris and all the stars get towards the horizon, they appear to slow down because of something called atmospheric refraction. I'll say that's the convergent point caused by perspective. He'll say it's the bending of light. I don't know which one it is. We can't prove which one it is, but there are two equal and opposite arguments to explain the phenomenon, and we can't tell which one's which. But the point is, it doesn't move at 1 degree for every 69 miles, which it must do if we're on a sphere. So there's an explanation.
Yeah, but it
No,
wouldn't
because
do,
we're not on a perfect
because-
sphere.
No, I know.
That's
but,
why.
I know, but listen.
So that can cater for it.
Listen, the point is that the claim on the model is that it does 69
Yeah,
miles 1 degree.
But
It
that
doesn't
might be
really do it
that
in
might
real
be using
world.
perfect spherical mathematics, whereas we're not on a perfect sphere.
I know, I understand. But the claim is 69 miles for every 1 degree. But it doesn't actually do it real world. The explanation for why it doesn't is where the argument falls.
No, because I just said why.
yeah,
I just said because they're using spherical mathematics when that doesn't necessarily apply.
the oblateness
because
of-
we're on
the
an oblique
oblateness,
spheroid.
the oblateness is minuscule to the point that it wouldn't change the 69
But
miles
science,
in every
but
1
there's
degree.
so much stuff in the world that changes by a minute amount, and you're just saying that we should discard it because it's so small.
I'm not. What I'm saying is that there are two equal and opposite alternative explanations, and we can't distinguish which one's correct. Is
But
the
you
light
can use
bending,
other, you
or
can use other
is
scientific
it
principles to give more validity to the idea of refraction, because you look at water and light entering water,
Yeah,
and
but
then you
that's
do the whole.
that's a hard barrier, and we apply Snell's law, right?
Well, you apply the fact that when you the change in medium.
Yeah.
There's a change in
That's
medium from
Snell's law.
vacuum to atmosphere.
Yeah, it's basically no, not really.
Well, there is.
It's a
There is,
it's
because
a
here
gradient,
we have
isn't it?
air.
It's not a change in medium. Snell's law applies to a hard change
It's
in
a
medium.
fairly. It's enough that makes it. But
Okay,
that's, but
all right.
also it may not be
Let's go back
as
to
hard
basics.
as water, which is why
Does
when you
light
enter
travel in
water,
straight lines or does it follow a curved path?
It depends what it's going through.
Yeah, it does. But does it follow a straight line? What's the base principle to start with? Is it a straight or is it a bend?
It's a straight, but it's completely
It-
derived
it-
on
that's
magnetism,
like-
which
that's like
the
saying-
Earth is magnetic.
That's like
Yeah,
saying,
it-
do I run or
electromagnetism.
walk?
It's
Like, it
straight,
depends what's going
applying Fermat's principle on the trajectory of light that states that light travels in straight lines but deviates from straight in all directions depending on the medium. It's the isotropic medium it travels through. That's how light travels in the atmosphere. It deviates from straight in all directions depending on the atmosphere, the isotropic, non-homogeneous state of the atmosphere.
on. Not just medium change though, because then you also have to take.
There is no
into account-
medium change. We're in the same medium, but it's
As
non
space.
No, the light in the atmosphere. Oh yeah, space. So when it goes into the atmosphere, the argument is it's changing medium,
It does.
but it's a gradient. It's not
It's
changing
still
with a hard
change, but
layer.
it still changes.
No, but it does
Yeah,
change
but it's
through
not a
hard
line,
layers.
though,
It
is
does
it?
change. It
Snell's law can't apply. Do you agree?
No, but it does
No, 'cause
change
Snell's
through
law
different
does apply.
mediums.
It's a gradient.
As you go through the atmosphere, there's different levels of pressure, there's different levels
Yeah.
of
But you're-
magnetism. So it does
Yeah.
change consistently all the way down.
No, it's not. It's
Until it
inconsistent.
enters our
It's,
like
it's
level of
non-isotropic
atmosphere.
and non-homogeneous. It's not consistent.
Where's your evidence for that?
That's the definition of the atmosphere.
Well, it's not.
The atmosphere is defined as non-homogeneous. I can get it up. I've got citations for me on my phone.
But then non-homogeneous just means it
And
doesn't
not-
hit
It
a
doesn't
single
confirm-
barrier and
yeah.
change,
Yeah.
but it can
That
change
means you
multiple
can't-
times.
But that means you can't use Snell's law to explain refraction of going into an angle.
You can. You
can't.
can. It's just you're looking at Earth. This is the same as when you're looking at the scientific method. You're saying one thing is the absolute. When you look at the
Snell's
ground,
law.
when you look at the ground to space, you would take the medium density of the atmosphere and you would calculate the angle based on that. But because it's sort of different rings, it's non-homogeneous, they're different densities. It would change a little bit every
That's
density.
right, that's
'cause
the
you look-
non-isotropic
and that is
bit.
no, and that is Snell's law, just applied on a microscopic, not even microscopic,
No,
because it's still a big area.
Yeah, I
Because
understand
Snell
what
is
you're saying.
saying-
You're
no, Snell
reducing
is
it down
saying
to
that
macroscopic.
that
Right, I
it's,
get.
that it's changing based on.
So if we can agree that Snell's law applies because it's non-isotropic, but only at the macro scale, yeah, we can agree.
No,
that.
not just because it's not. Snell's law is applying because it's a change in medium. It's just
It's
happening.
non-isotropic and
It's just
non-homogeneous.
happening in different.
I agree.
It's just
We
happening
can
in
agree.
multiple stages
We can
instead
agree.
of.
We can
well,
agree.
we can agree that Snell's law applies.
Yeah, well, provided we're talking at the macro level, right? We're not talking about a hard barrier between two mediums, space and Earth.
But
Well-
there are barriers in the way.
Provided we're talking at the macro level, we can agree.
No, because even
There's no hard line. You
Because
can't
when you're
apply Snell's.
even,
There's no hard line.
you can. It just applies in different. It just different gradients.
Only at the macro level. We have to agree it's macro level, or we can't apply Snell's.
Why not? What's the
Because
the
it's
maths? What's the
non-homogeneous.
maths in
It's
Snell's?
non-homogeneous and
What's the maths in
non-isotropic.
Snell's that says you can't?
It requires a barrier, a line, a change in medium.
But that's what I'm saying. You apply Snell's laws just repeatedly
Yeah,
over the
so
course
it's
of a
macro.
diffraction.
So we're applying it on the macro level.
Well, and the micro levels as well. But if you want
Sure.
to get it, if you want to get it from Earth to space, then yeah, of course that's a macro level because it's a macro distance. But applying Snell's law across each one of those would give a more accurate representation of what's happening than using Snell's law. Is it Snell?
If-
I've lost his name.
Snell.
Across the whole
Now,
thing.
now
Same as the trapezium rule and
well, put it this way:
integrating curves.
if we can agree it's at the macro level, we can move forward. But I'm not prepared to move forward if it's not, because it is non-isotropic and
Both.
non-homogeneous.
It applies on both.
No, it doesn't. It
can.
only applies on both if there's a hard barrier line between the two mediums. That is
No.
Snell's law.
But what's the maths behind it that says it has to be a hard
Angle of
barrier?
incidence equals angle of refraction.
But you can use that over several instances.
Yeah, that's why I'm
to
saying
almost
macro level.
generate a curve.
All right, so listen.
Instead of. Well,
Let's
I'm
just
saying
agree.
it applies on
Let's
both.
just agree. Let's move forward. Snell's law states that an angle of incidence equals the angle of refraction when it goes through the medium.
Yeah.
Now, Fermat's principle on the trajectory of light states that, yeah, it's getting cold. Fermat's principle on the trajectory of light states that light will take the path that takes the least amount of time to get through the medium, and it deviates from straight in all directions. It doesn't follow a curved path. It deviates from straight in all directions. Now, this is where Snell's law comes into this. The refractive index of water vapour evaporating off the surface of standing or tidal water is less dense than the air it's in. That's why it rises. When you're looking at objects on the horizon, you're always looking through an amount of vapour. It varies, but it's always water vapour because it's evaporating, but it's less dense. Now we know that when light's going through less dense medium, it bends away from the norm. the normal, it bends away from it. But that's not consistent with the claim that you can see behind the curve. So when we're looking at Polaris going down to the horizon and it starts to slow down, the argument is it's still there, but it's being bent, the light's being bent because of refraction through the atmosphere. The trouble is it's bending the wrong way. Because when we're looking through the atmosphere towards the horizon, the
bending
light's
the right
bending up.
way.
It's not, it's bending from the light up.
Because you're not looking at your light out, you're looking at
the
that
light
light
coming
in.
in. Yeah,
which
but
means as it's coming in,
It's deflecting away
instead
from
of
you.
coming at this angle, it's gradually going up,
Yeah.
which means that as it's falling, its apparent position, because of the time it takes for the light to get there, is slowing down.
Right.
Because more of the light is
Right.
bending up,
So,
surely.
yeah, that's right. So now we've got an apparent position.
Because otherwise, if it's just straight lines, it'd be constant. And if
Yeah,
it was curving
that's right.
down, it would speed up.
That's right. We're agreeing at this point. We agree that as
But you
it's,
said it was wrong.
hang on. Now we're talking about an apparent position of a star that we believe is apparent. Where is its real position? Do we accept that we can backwards calculate refraction to prove that its real position is somewhere that we don't see it? In which case I'll say that's not scientific method compliant. Or because the observed phenomena is what we're the dependent variable.
The observed
But
phenomenon
why
is the
didn't
fact
you
that
just
it's
use the
bending.
exact same... so
Bending.
The-
Is it bending or is it following
Well,
a
this is
wave?
the thing. The observed phenomenon is the fact that it's slowing down. Then the next stage of scientific method is inquiry. Why is that happening? What do I know? What other scientific things
But
exist?
now we have two pieces of
Then
science
why
that
don't you
conflict.
just take a different star? If you want to experiment that, then why don't you take a different star that you can still see, calculate how much the angle, whatever, is actually
Because
changed, and then apply it
yeah,
to
yeah,
the same
because
one? Because you're
the-
then using an observed calculation
the answer
to
to
something
that
that you
question.
can't see.
The answer to
Because
that
it must be
question.
the same.
The answer to that, no, it's not. That's the point.
No,
It's
but
not the
if you're
same.
saying a light's entering at a certain angle, that's going to be the same. No, as it goes down, doesn't matter where it is, it's going to be follow the
Yeah, but
consistent.
You're assuming. You're making an assumption there that we know is not.
Okay, so say I did on 99 stars, so that mean I can't assume it on that one.
Yeah, but it doesn't do it. That's what I'm saying.
it
All of the
does.
stars. No, it doesn't.
But
All
it
of the stars,
does.
not just Polaris. All of the stars slow down as they get to the horizon.
Yeah,
there
so
are
if
two.
you just track
because
that,
there's some
the
form
several...
of refraction which is happening as
Yeah,
it
and if you
comes
track
That's one
that
explanation.
99 times
the other
over.
explanation,
That's the other one.
the other explanation is that the plane is a flat plane, and it's the convergent point, and they're getting further away, so they're taking longer to get to the horizon
wouldn't work.
because they're getting further. It works.
That wouldn't work
Well,
because if
you
it's
get
no,
2D model
'cause
in
if
a
it's
3D
flat,
world.
if it's flat, the light's coming in
I'm,
at these
I'm
angles,
demonstrating
so it would
that
be
there are
constant.
equal and opposite, or
But
equal
it's
and
not.
opposing
It's
positions.
not because when you look at it on a flat plane, the light effectively would look. It would look a bit like a protractor. It would come in at straight lines.
Yeah, but
Yeah.
over time, they would get closer and closer together as they get to
No,
the
they
horizon.
wouldn't. It would be constant.
They would because they're getting further away from you.
But where's the convergent point if it's flat? Where's your
You
convergent
can't
point?
see it because the convergent point is a layer.
So
It's
does
called-
that mean
it's
that if
called
we're on
a-
a flat Earth,
It's
we're
called
spinning
Airy's,
like this?
It's called Airy's diffraction. If you look at a single light source, just any light source over a long distance, if you have two light sources that are close to each other, eventually they will merge and become one. So what we perceive as the horizon is actually the convergent point where everything. It's called the. What's it called? The circle of confusion as defined by Airy. Airy's diffraction is literally it's a circle of confusion where everything merges into one that we perceive as the horizon, but it's actually an optical effect caused by the limited angle that our eye can't see. We have a limitation
What
of vision.
causes it all to move?
What causes it all to
The
move?
stars. Why are they moving? If we're flat, why is it
That's
moving?
what we're asking. We're asking: is it the Earth turning or is it the sky?
But then if
The
we've
entire universe that
but
is
then if we
turned.
but then if we've used maths and
If it was the Earth-
theories
if it
and
was the
no,
Earth
no,
turning.
because if we've done loads of scientific experiments, we've
Yeah, yeah.
looked at stuff, we've applied theory, we've observed, we've
Forgive me,
tested,
let-
we've done
let me
methods,
help.
and then that has all concurred with the fact that we are a globe spinning while other stuff is
But it
spinning
doesn't know.
around
That's the
us.
point. So we've got Sirius. The closest star to us is Sirius, right? Or one of the closest.
Technically, it's a binary.
It's one of the closest stars. It's about I think it's 6.7 light years away. It's about that. Sirius, it is. Look it up.
The Sirius is a binary star system that's ages away. We don't have a star that's that close to us.
Look up the distance of Sirius. I think it's
The closest
6.7.
star to us is the sun.
Pardon?
Well, yeah, no, other than the sun.
Yeah, we're not talking about the sun. I'm going to give you an example here where astrology does not agree with the heliocentric model, and we can argue and discuss why, but it does.
Also, the nearest star is Alpha Centauri,
Centauri.
Yeah. How far away is it?
4.3.
Right. How far away is Sirius? Because that's the one I'm going to reference because it's next to Betelgeuse in the night sky. I think it's 6.7 or 6.9 light years away.
Okay, Okay, 8.6.
8.6, right? Remember that number. Now look
Okay.
at Betelgeuse, Betel,
Yeah.
and I think it's 467 light years away. I think from memory.
How much?
I think it's 467.
652.
652, right? So
Okay.
we've got 6.7 against 652 light years. That gives us a ratio, and it's about 1 in 50.
But they're also not the same star.
No, I know, but they're next to each other in the night sky, so we should be able to observe stellar parallax at the ratio of about 1 in 50. So what we should see,
Wait, what stellar parallax?
exactly, there is no
No,
stellar
no, no, no.
parallax.
What do you mean as we should observe stellar parallax? In
All
what
right, so
sense?
let's give this an example.
What's your
right?
definition of stellar parallax?
My definition.
Yeah.
The amount that one star that's close to us will move relative to the star that's millions of miles away behind it. So Sirius will parallax with Betelgeuse because Sirius is much closer.
Okay.
So basically, what we're talking about here, the scale is kind of like this guy stood with the
Oh, yeah,
camera.
no, I know, yeah.
And then you got Betelgeuse, which is the Burger King thing in the
Yeah, no,
background.
I know, yeah.
And a little tiny movement here makes the guy with the camera move a lot.
Yeah.
The ratio is 1 in about 50. I mean, you can do the maths yourself, but it was 6.7 light years to whatever the other.
652.
Right, well, it's basically 1 in 50, roughly. That means that we should see parallax of Sirius at a
skirt around
No, that's
until
not
you.
true. I haven't answered every single question you've asked. You might not like the answer, but that doesn't mean I've not answered
No,
the
I
question.
disagree with your answer.
Yeah, you may disagree with
I
it.
dislike your answer the way you phrase
Sure,
your answer.
but going back to the point, Earth turn, where's... What I'll say to you is, try and prove for yourself that the Earth's actually turning. There is no experiment that proves that the Earth's turning.
There's plenty.
There isn't.
There's plenty. You just don't agree with the method in which they've done it. I do agree with the method in which they've done it. That's the difference.
So
You don't like the methods.
it's not that I don't like the method.
That's what your issue
It doesn't prove that the Earth's turning. Now, if you think it does, that's up to you to accept. And I'm not going to say that
But
you're
okay,
wrong.
okay, there's more proof that the Earth is round than there is proof that the Earth is flat.
So how would we demonstrate that the Earth's round? When you say round, do you mean
There's
spherical?
more proof.
Do you mean spherical?
Oblate spheroid.
Right, because I mean that signpost is round, but doesn't mean it's a sphere, right?
Okay, oblate
No,
spheroid.
please don't try and patronise me.
I'm not,
What is
I'm not.
round and
Okay,
what is
no,
Words are
spherical?
important. Words are important.
Okay, not sphere, oblate spheroid.
Oblate spheroid, right? All right. So let's go
go
with
with
oblate spheroid. What's the evidence that we are an oblate spheroid?
Observations. The fact
Right,
that
name one.
The fact that the southern the southern hemisphere has completely different constellations that we can never see from up here.
But what does looking into the sky prove about the shape of the Earth?
It proves that we're looking in different directions.
So what?
As I was saying with that and that.
Yeah, but you're looking in different directions. You're not looking around a curve. You're just looking in the
But
different
that's what I'm saying,
direction.
but we're so far apart that it's curved to the point where, okay, then on certain nights in Russia, they won't see the same thing as us. The moon. The moon
So
is a
what
prime
proximity
example
would
of this.
explain that? No,
No,
the
it
moon.
wouldn't.
Why
It's
do we never
different
see the
directions.
backside of the moon? Because it's tidally locked.
Because
really?
no,
That's-
it's not tidally locked. It has the same rotational period as Earth.
Yeah, it's called tidal locking.
It's not tidal. It links with it. It's
called tidal
It's
locking.
It's gravitational effect on the tides, but it's the fact that the orbital period is the same.
Yeah, but the reason why we see the same side of the moon is called tidal locked. That's the phrase that they use. It's tidally locked to Earth. I'm not saying that that's true. That's what they tell us is true.
That's the wrong causation.
Well, maybe, but I'm saying that that's the explanation. That's the word that they use to describe why we see the same side of the moon. They call it tidal locking. But my point is, try and prove to yourself, and if you think that
I have several times. Quite frankly,
I'm too busy beating these two up here.
yeah, but I have to myself. I have proved the issue that I have, and I
Just tell me, when you say you prove to yourself, what
the evidence that I've read up upon, I believe.
I believe.
Everyone
I'm
has to
alright with
believe
that.
in
I'm alright.
something.
Well, I'm alright with you admitting that that is your position. It's a belief-based thing. I'm alright with that. I've probably got my own beliefs.
Yeah, exactly.
Right.
That's everyone's position.
But all I'm trying to
As
say.
a human being, all you can ever do is believe what you
Look, the other thing is
basically
there are
prove.
some
Yeah,
beliefs. There
but
are
science
some
isn't
facts.
about belief, though, is it? It's about proving what's causing the phenomena.
No, but everything's not belief because you're on a basic human level of belief.
Yeah, but we're not talking about humans. We're talking about science.
Also, there are
Science was
some.
invented by humans, so therefore it's a human thing.
But then there are also, no, hold on, that's the thing, there are some beliefs, there are some facts. Maths is an unchanging language, which everything, it's effectively like a
No.
roller coaster.
Let's not do the math thing again.
No, we are doing it again because it's fundamental to this whole argument of
listen,
saying,
it doesn't
no,
prove
it
cause.
does. What I'm saying is that there are rules that everything has to abide by, and that is written in maths. We just have to find what that maths is. And when that maths is adhered to, that is a version of proof.
Yeah, but it's not cause. It's explanation by correlation. It's not cause.
But if that explains the cause, then surely that explains it.
Yeah, explanation is not cause. You can explain different causes. Me and you can both witness the same bank robbery, right?
Yeah.
We'll both give similar but different versions of what we saw. We both saw the same thing.
But what I'm saying is there are so many explanations that would only work if the Earth is round or oblate spheroid, whereas there are so many arguments for flat Earth that is contradictory to what has already been proven in maths.
Well, we haven't found one yet.
We've literally been talking about them all day.
Right, so now I'm going to go back to what I said to you before. I want to respectfully request that you allow me the time to look into that paper that you cited for time dilation. But in return, I want you to go away and look at the proof that you accept. Either that gravity's thing, that we're turning, or that we've got curvature. And if you can find evidence that you accept is true, let's reconvene at some point in the future. Look me up on YouTube. Tell me, like, what's your name? I will remember. Cameron. Just say I'm Cameron, and then we'll sort something out where we discuss it and we'll have the conversation. We won't be bitchy about it.
No,
But
it's
if you can prove something to me and I can learn something, I want to see it. But what I'll say is, if I can also show you how something doesn't comply with scientific method, with citation in science that says that it doesn't, at least consider that it might not be science. If we can at least say that's a reasonable position. We don't have to fall out, but I do want to try and learn shit. And if you think you can prove something, I want to hear it. Same for you. I mean, I know you won't. You hate me, that's fine.
The thing is,
No, I
all
don't.
the
No, the
proofing
thing
was
is, I
found
don't.
in
The
maths.
problem that I have is that the way you display your argument sometimes is arrogant to the fact that you sound, and you sort of believe yourself. You sound to the fact that you sound like you know more than top leading scientists.
I know scientific methods.
I don't think you know it better than top leading scientists.
Well, I know what the first
They
stages of
spent
learning
don't-
30 years.
That's what I disagree. Is the fact your claim that you know scientific methods and this is how scientific method works better than hundreds of thousands of scientists over years.
Yeah, but a lot of scientists that claim they're doing science aren't actually doing, they're not complying with scientific method.
But they are.
Yeah, a
But
lot
then
of
what
them
are they doing then? If the scientists aren't
applying,
doing science, what
applying
are they doing?
pseudoscience
How
in the
do you
belief.
know
So
that?
how come we don't
How
call
do
them
you know that?
pseudoscientists?
We do. The definition I gave you
No,
before.
you do. You
No,
know
I.
what you do.
No. You don't because you. Let's call you a scientist. You won't call your. Yeah. You won't call your fellow scientists pseudoscientists because you'll be
They believe in their
blackballed.
scientific method.
doing science incorrectly, you would correct them. Because that's part of being
Right,
science.
but the problem we've got is, look, definition of pseudoscience, a collection of beliefs or practices.
What's the definition of science?
I've told you,
No, go on, Google it.
it's the observation.
Google it. That's a misbelief of science, isn't it? There's a lot of science that out
So
there that
before-
I disbelieve, like a lot of that.
So
I disbelieve
listen,
that. I think that's pseudoscience.
so before the answers come up, right, I'll
Yeah.
tell you, it's the observation and the experiment of the natural and physical world. Okay? Science definition. The intellectual and practical activity
The
encompassing
intellectual as well. Most, but that's not just practical, that's also like computational theory. It's intellectual, so,
Touché.
which is what you just...
and practical activity encompassing the systematic study of the structure and behaviour of the physical and natural world through observation and experiment. That's why we have experiments.
But you also, before, discredited me on calling computational and theoretical science as not being true science.
It's
So
not,
there.
because we're
Intellectual.
Intellectual.
An intellectual activity, that implies theory.
of the physical and the natural
and
world.
actually, because it's explaining the physical, that's what I'm saying.
Alright, so and natural.
Explaining the physical.
How is theoretical physics natural?
Because everything in this world is natural.
Theoretical just means it can't be
No, because
definitively
everything that
proved.
you're explaining is a natural
Is that
world.
natural? Or
It's
is
made
it-
from natural materials.
Is it man-made?
It's made from natural materials.
Is it natural? Does it
Can you
exist in the
down?
natural
Okay, I
world?
can bet that you can get everything down that into a hydrogen atom. You can.
Is it natural? Is this natural or man-made?
It comes from that. Does it? Or just
They're
what does
not
it come from?
exclusive.
Man made it.
But they're not exclusive.
From what?
Yeah,
What did that
they're
man make
mutually
it from?
exclusive.
It depends. No, because on the
So
is no longer present, and so the reason of it falling is gravity.
Right. So would it have
Which
got?
can
Would
then be
it,
proved.
so would it have fallen if you never let go?
But
No,
also
because
because
the
it
cause
just
of that is my hand.
Yeah, you added energy to the system, right?
No, I didn't. No, I didn't add any energy. I let it go.
You used
No,
your muscles to
No,
do
I
it.
didn't, because if I let go, I'm not adding any downward energy.
You added energy by
Where?
contracting your
How?
muscles in your hand. You add by doing that.
No,
You're
I don't.
adding energy.
Because if
He's
it's
not
here,
adding energy, he's
I'm not.
converting
I'm not
energy.
at all.
Converting energy into
No, I'm
kinetic
not
energy.
at all.
Yeah, but
No, I'm not at all. The system of the ball has gravitational potential energy up here.
Yeah, but
when
you
I
need to
let go,
add
I'm not adding a force.
Dude, what I will say is the fact that you are, I will agree with the fact he's not adding energy, and you're not.
He's
you're
converting
adding,
energy
you're
into kinetic.
converting energy, but what he could have
Which
easily
energy's
done.
Because
No,
it
but,
already-
it,
it
no,
already
but what
has
gravity
GP.
does is convert into kinetic. What it could easily do is just form chemical energy on the
Gravity doesn't
inside.
convert it into kinetic energy.
Well, it does, because it's transfer of energy.
Einstein said it's not a force. It
Kinetic
can't.
energy is the definition. It's gravity.
No, it's not.
You
Citation
do
for
gravitational.
that.
Okay, actually, it's
Nobody
kinetic
in
energy.
science
It's
has ever said
gravitational
that.
potential energy.
Yeah,
No,
that's
are we
what
not
I'm
talking about
saying.
entropy?
It's gravitational potential energy that he's
Yeah, we're talking about entropy.
Can I just interject for 1 second? Right, I've got an anti-gravity device here.
Smoke.
Yeah.
Explain that.
Explain what?
Explain what?
Explain why the smoke's going up.
Because it's less dense.
Because it's less dense and there's fluid mechanics involved.
not
with the
gravity
air,
then,
which-
no.
Gravity's
why
not
did
the only
that fall?
activity.
No, because gravity is effectively pulling the air underneath that.
No, because
One's
it's
going
really
up, one's
hard
going down,
moving,
isn't it?
because whenever
You can
gravity
theorise
acts
it.
on
You can theorise it with maths, and then when you
Also
apply it with
air.
maths,
This is Mr. Cheswick, who's come into the frame.
So squat technically would be anti-gravity.
No.
No?
Anti-gravity is a completely different concept.
Well, that's a
No,
concept,
it's not,
isn't
it's
it?
not
Yeah.
reversing gravity. It's just that the
Right,
medium
and
around
the force
it
of
is
gravity
more
is no
dense,
stronger than
so it goes
upwards.
underneath it effectively. and
Why
lifts
don't we sink in the Dead Sea? You know the Dead Sea where it's very
Because
salty.
because of the density.
Right.
Because the density of the water
But-
means that you're less dense. Not that you're like lighter or that
So
you're an
where
anti-gravity.
does gravity fit into that?
Because it's pulling the water underneath you.
Right, but we know it's not a pull because Einstein said so.
But it is.
Is that not the pull?
It is a pull. It is a pull. It's the effect.
Oh.
It's the effect on a mass which pulls it
Right,
towards
so you believe it's a pull. Is there any
Yeah.
science that shows gravity to be a pull?
You don't say it's a pull, okay? So it's a force acting downwards.
Force, right? But we know
A
that
force
Einstein...
acting downwards, and then you have
Right,
a
well,
force
we
acting
know that
upwards.
Einstein said it's not a force, and we also know he defined down as the direction in which time travels more slow. So how is this a force?
Okay, but you can't use up. Personally, I would never use up and down because up and down is completely
Relative to the human.
Ex-military Dave. Hey, I'm very suspicious.
Do me a favour, just say that into that lens. Up and down is relative, just say that to that lens. Why?
Because I'm not going to do anything you ask me.
Oh, okay
No,
then.
no, 'cause
You're one of them.
Yeah, absolutely not.
Okay then.
But that is completely
Right,
relative.
just for the record, she did say that up and down were relative states, relative directions.
Up and down can only be really used in terms of quarks.
What's a quark?
It's a
Fundamental particle.
Is it real or is it virtual?
Real.
Really?
They've been proven.
Really?
yeah.
It's CERN.
Well,
Yeah.
that's a debate.
Up,
another
down,
debate.
top,
It's not another debate. That's literally what they do in CERN. I've been there. I've seen the research.
I-
I've looked at the equations.
Yeah, and I've seen.
it.
Have you
Like,
looked? Well, all right. Let's move away from quarks. I'll give you the quarks one for now. I want to move away from it. What I want to get back to is how do we prove in science that the Earth turns, that we've got gravity, or that the Earth's got a curved surface? We've got to measure something,
because
right?
of your first scientific method that you
Is
keep
observe
coming
a
back to.
phenomena.
You observe it.
Right. So
You
what?
observe that stuff is moving.
Right. So where do we observe? Like so, gravity, right? Where do we observe?
No, stars. The
Stars.
sun. Stuff is moving somewhere.
Right. So you think looking into the sky proves the shape of the Earth?
It proves that there is an occurrence that we need to sort out.
Right. What's causing it? Earth turn or sky turn?
Well, that was the first questions, wasn't it? Of
So how do we prove which
what's
is
it,
turn?
Copernicus
So we've
versus
got,
Galileo?
there's three ways we can prove momentum in this context. We've got mechanical gyros, ring laser gyros, fibre optic gyros, and we don't have anything else that goes beyond that science at the minute. They are the three sciences. None of them prove that the Earth's turning.
Gyros.
The mechanical
measure-
gyros show no 15 degrees.
Don't gyros measure? This is
Yeah,
actually
they
just a question.
maintain-
They measure level, don't they? Like the plane of something, not its momentum.
No, a mechanical gyro maintains rigidity in space. If you hold the gimbal and then move the gimbal all the way around it, the gyro will stay still.
Yeah, but that's measuring plane, not
It's measuring what?
the plane that it's in, not momentum.
Yeah, you can get.
Momentum is a movement.
That's right. But we're
So how
supposed to
does
be-
putting something still measure, and the fact that it moves in the
because
same
the
way?
gyro stays still, but the gimbal around it moves. That gives you your
But what's moving it?
nothing.
Well, there is something that's moving it.
It's not moving. It doesn't move. That's what I'm saying.
You just said it's moving.
No, if the Earth's turning, the gyro will move. The gyro maintains rigidity in space, but the gimbal around
No,
it moves.
no, because it doesn't. Gyros don't measure momentum; they measure plane.
no.
They measure the plane that something's on. If you sit
No,
something in a
mechanical
plane,
gyros
you
measure
then
momentum.
move it around.
That's right.
That's not measuring momentum.
Well,
Because
you're moving it around. So what's that if it's not momentum?
It's measuring the plane. It's measuring the flatness of something. You're measuring what's in the middle isn't moving. Regarding that's not momentum.
The gyro is
Momentum is how much something is moving over a period of time.
The gyro is not moving in the middle. It maintains rigidity in space.
The gyro is the whole.
The hand around it moving it is showing the momentum of the hand around it moving it. But the gyro will stay still. It's the gimbal around it that moves that demonstrates that we're in an
So you're saying
inertial
the
frame of
gimbal is
reference.
space and the gyro is Earth.
No, I'm saying that the gyro maintains rigidity in space, and if the Earth is turning, the gimbal around it must turn with the Earth, because the gyro is not moving and it doesn't stay locked to the Earth. It maintains rigidity in space. So a gyro's gimbal has to show that momentum of the Earth
No,
turn.
because you're applying two different concepts.
What's the first concept?
But you're saying that there's a stationary object with something that's forcibly being moved around it, and
that
therefore
would be the Earth turn.
no, you're saying that there is something in the middle,
Yeah, the gyro.
and something is moving around it.
Yeah, the
you're
Earth.
then saying that the Earth, that when you just place it by itself, it's not moving.
Yeah.
But your first argument is that there's something moving it, So when you leave it alone, of course it's not going to
We're
work.
at crosswires. A gyro, fucking hell, he's loud. A mechanical gyro maintains rigidity in space. The gyro itself, the spinning disc, does not move.
But what's there to move it?
The Earth turns.
But that's not how that's not momentum.
Yeah, it is.
No, it isn't. Momentum is if I run in that direction.
That's acceleration.
No, momentum and acceleration are linked. They are. What's the equation for momentum?
They're using what?
Let's stick with physical. Like it's
Right.
Momentum.
but it's linked to acceleration.
Yes, it's a.
There's a difference between velocity and acceleration.
Word.
Acceleration
Yes,
is the rate of change,
No,
whereas momentum is.
acceleration is the rate change in velocity.
Yeah, that's right.
Yeah.
But they're
if
different
the Earth-
concepts.
If the Earth's rotating, we've got two axes of rotation, right? We've got one axis that's measuring the turn of us as we go round in a ball, but the other one is measuring the actual momentum of going round a curve.
And that's angular momentum.
Yeah.
W equals mr. There's no acceleration in that at all.
There is, because we're on a curved path. The curved path is an acceleration.
But that wouldn't be picked up by a gyro, because gyro.
It does pick it
You'd
up.
have to place a gyro at the centre of the Earth, where it's stationary.
No, because you've
and
got
then-
a rim velocity,
That's
a
not
tangent.
what-
We've got a
mechanical
tangential
gyros don't measure momentum. They
Do
do.
they measure inertia?
They measure the inertia,
Inertia and momentum are different.
like in a plane or a boat. As the plane or boat work around the gyroscope, they can tell the pitch, the yaw, the roll of the plane or the boat based on the gyro maintaining its rigidity.
I've got it. With a gyro, you have to like smack it or something for it to move, right? And then it stays moving, but the centre doesn't. So,
Let's
that is the
distinguish
model.
between the gimbal and the gyro.
The gimbal. So the gimbal. If you like hit the gyro, if you
Yeah.
hit the gimbal, that will move around the gyro in the middle.
Right, yeah.
The reason that doesn't work in space is because you're not at the centre of the rotation.
Well, we're not in space,
So
so
it
let's do
doesn't.
it on
No,
the
you
Earth.
said in space.
No,
it
it
doesn't
maintains
work.
rigidity in space.
What? Nothing moves.
The gyro doesn't move. You can move everything
that's-
around it.
But why? Why though? What would cause the gimbal to move?
An acceleration, of course.
No, an acceleration and a force are two different things.
Yeah,
They're linked,
either will
but
do.
one needs to cause the other.
Right. So
But if you place the gyro at the centre of the Earth, but it's been. Yes, it would.
what point are you making? Are you saying that
I'm
gyros don't
saying
measure?
I'm saying that you're linking two different concepts and trying to make them equal the same. Having a gyro, if I left a gyro here and just left it, it wouldn't move.
Yeah,
But that's
but
because
it's
there's.
turning,
But that's
so
because
it
there's. No, because we. But if we're turning, it's because there's effectively a ball around it which moves with it. Clouds and stuff like that. We're all
So,
in a ball moving together.
A bike tyre, when you spin a bike tyre and the circumference spins round like that,
Yeah.
are you saying that if you put a gyroscope on that, it won't show a movement?
I'm saying no, because that's not very
know, mate.
That's not microscopic level.
Oh, we'll probably get tired down really well, so. Maybe next time.
A gyroscope?
Maybe next time.
We can measure 15 degrees an hour, we can get a clock mechanism.
But that's because we're working but on a macro scale. The gravity's working over such a large area that a tiny.
What gravity? We're on about Earth turn.
No, because it's the gravity that would move it. Because the force that would be moving is not the acceleration. It's the gravity in the centre.
The force that would move
But
what?
it would keep it solid because it's moving. If I had a diagram, it's so much easier to explain.
No, you're saying that it doesn't maintain rigidity in
It
space.
would have to be moving so much quicker than.
You're arguing now that it doesn't maintain rigidity in space because it moves with the Earth turn. Is that
Yeah.
what you're saying? That's not true. A gyroscope doesn't do that.
You just said it maintains rigidity.
Yeah, so if the Earth's turning, the gimbal will move around it. The spinning disc in the middle stays, it never changes its position. If you can keep it running long enough, it never changes its position, right? You can move all the way around it in any direction, and that disc in the middle will stay where it was. Because it maintains rigidity in space.
But that's the angles on which it's being acted upon. Because the only force that would be acting is gravity, not the Earth's rotation. The angular velocity is.
Think about it.
Angular momentum is not a force. It doesn't act.
Have you ever played with a gyroscope?
Yes.
Yeah, you can feel it resisting you as you move it, right?
Yeah.
Right, that resistance is what keeps it stationary and it maintains that rigidity always while it's spinning. Don't know why, it just does. But that's why you can move everything around it and then you can see that stays where it was, whatever angle you put it on. Nice to see you, arsehole.
Hey, not bad. What is that?
No, I know. You bottled it, that's why.
No, I didn't bottle it, but I just thought it'd come down and just say, like, look, here I am, you know what I mean?
I appreciate you coming down, man. I really do.
Yeah.
Don't be an arsehole to everybody. We're on the same side.
I just take the piss. I mean, you know, so I just say what I say, you know what I mean?
I appreciate that. Hey, can I use your fucking video now in the future?
I told you, I don't trust Mark Sargent and all them, so...
Who said I do?
Yeah, but you're doing things with them, you know what I mean? It's like...
Yeah, but they're not my enemy. I don't necessarily trust Mark Sargent. I think he might be a bit dodgy. He's never commented on a single video of mine. But he's all over Roxanne's. He's all over Patricia's. He's all over everybody else's but mine.
It's like, you know, mate, like, I've got my stance, you know what I mean? And my stance is that loft for like a better hand, just as fast as I can throw them, you know what I mean? And, like, you guys seem alright, but because you're...
We're heading off with fun, mate.
Look me up on YouTube and let's resume. Look at them teeth there. Have a good day, guys. See you later.
Yeah, so...
They were really
you know
good.
what I mean?
They went on for about, what, 90 minutes? That was like a game of football, that. Yeah. Have you got the build-up of lactic acid in your shoulder? You should have used my stand. I feel like that scene on Dumb and Dumber. I feel like the scene on Dumb and Dumber where he goes, "Here, Harry, have some of my gloves." And he goes, "How many gloves have you got?" And he goes, "I got 4 pairs." And they chase each other around and batter each other. You're going?
Yeah, so, that's it, mate, like, you know,